thank you for being part of this very exciting webinar about how we position agents in today's world that is ruled by artificial intelligence, and how the, let's say, traditional paradigm of multi-agent system is positioning and working together with a new approach of agentic AI. This is the third webinar in a series of interdisciplinary webinars in the framework of the Horizon Euro project ENFIELD. And Olivier Boissier and me, Adina Flora, I'm professor at Polytechnic University, we organized this webinar. So it will start with a short presentation of the ENFIELD project that will be done by Pankaj, and then our distinguished speakers will start presenting their contributions. The format of the webinar will be like this. Each speaker will present the contributions, and the participants will have the opportunity to ask specific questions related to that presentation. And then in the end, we are going to have a discussion session with open questions in which everybody is free to ask any question related to any presentation or to any aspects of agent design and the future of agent research, but also to make comments and so on. So we are very much relying on your active participation in some discussions that I think will be beneficial to us all. So this webinar is recorded, as Olivier said, and the recording will be later on available on YouTube, so that your colleagues that could not attend the webinar will be able to watch what we have said, to criticize us later on YouTube. So now I give the floor to Pankaj. And I want to thank very, very much before Olivier for all his efforts in organizing this webinar. So before giving the floor to Pankaj, Olivier, please say also some words.
Yes, thanks to everybody to participate to this webinar. Thanks for the speaker who accepted our invitation. And this is a great opportunity to discuss how we connect multi-agent systems with agentic AI, and how we can envision to use these technologies for human insight. And so I think that we have two sessions. The first session is dedicated to lay the basic knowledge about multi-agent systems and start to discuss about the connections about multi-agent systems and agentic AI. And the second session, after a break of 10 minutes, we'll go into the quite important questions of how we connect this technological world to the human society, and how we can envision to have responsibility and responsible AI in that approach. So thanks for everybody. Pankaj, the floor is yours. I let you share your slides for just giving a presentation of ENFIELD so that everyone can see the different important contributions that this project is building. Thanks. Thanks, Pankaj.
Right. Thank you, Olivier. Thank you, Edina. Good afternoon, everyone. My name is Pankaj Pandey, and I'm a senior researcher at the Norwegian University of Science and Technology, and also the project manager of ENFIELD. ENFIELD is a project funded by the European Commission in the area of European Lighthouse to manifest trustworthy and green AI. And the objective of this project is to mobilize the AI community to collaborate on various key challenges posed by AI domain in particular, and also to bring together various stakeholders from research, innovation, and the deployment domain. Now, in this project, we bring together 30 partners from 18 European countries, And this consists of a consortium of industrial partners as well as academic partners. And the balance of industrial and academic partners is roughly 50-50. So you can see that we are focused on the foundational area as well as the applied domain equally. Now here on this particular slide, you can see the logos of our consortium partners. And the project is being coordinated by NTNU, as I mentioned earlier, and the other partners are contributing on specific areas of either foundational areas or the industrial domains where we look into the application of specific AI solutions. Now the project is divided into excuse me, 4 pillars, that is the 4 foundational areas, namely adaptive AI, green AI, human-centric AI, and trustworthy AI. And in these 4 streams of artificial intelligence, we investigate the specific areas of how these you can say these features or traits can be applied to specific industrial domains, namely healthcare, energy, manufacturing, and space. And in this process, we have structured the work of this project something like this, as shown on this particular slide. That the work package 2, which is being led by IMT, particularly by Olivier's team, they are investigating into the 4 pillars, which I mentioned earlier, and then the application of research findings from these 4 pillars or the foundational areas to the 4 industrial domains is being considered under the ambit of work package 3, which is being led by Polimi from Italy. And the major outputs of this particular exercise we envision are contribution to education and training strategies in the domain of artificial intelligence, standards and certification, collaboration with the networks of other networks of excellence, contribution to the common research vision and roadmap, excuse me, and the development of a safety and security risk assessment framework to deal with the various dimensions of the research outputs in the under the ambit of Project ENFIELD. Now, ENFIELD is not only limited to research or application areas. We do have some third-party financing for activities such as third-party exchange scheme, in short, TESS, which is to support the mobility of PhD researchers in particular, and also for postdoc researchers and some early stage researchers up to the level of, let's say, associate professor. And through this scheme, we fund the mobility of, let's say, up to 6 months. Minimum is 3 months, maximum is 6 months, where the researchers who are selected, they are paid about 2,400 euros per month. And the objective of engaging this researchers through this mobility scheme is to contribute on the foundational research areas. That is the 4 pillars which I mentioned earlier: adaptive AI, human-centric AI, green AI, and trustworthy AI. For this test scheme, we allocated a total budget of 1.1 million euros, and we plan to have 4 open calls under this program. And I'm happy to announce that the fourth test has recently been concluded in terms of selection of researchers, and they will be starting soon, around the early next year. So we have nearly you can say concluded the 4 open calls we had planned for tests. Then the second scheme we have planned under this ENFIELD project is third-party innovation scheme, which is to fund the innovation or applied projects. And the objective here was to fund about 18 small-scale projects, each project receiving about 60,000 euro to work on the specific applied research areas, like focusing on the specific industrial domains. And again, in this particular scheme, we had planned for 2 open calls. And I'm again happy to announce that we have concluded the second open call. And so nearly have consumed all the budget allocated for this particular scheme. Now, in addition to these open calls, we also have planned for several summer schools, hackathons, and other activities. Now, since this project started in 2023 and is supposed to conclude next year in August 2026, most of the activities have been concluded, or just a couple of activities are remaining, and I would encourage you to join and participate in the upcoming events so that you can learn more about the project and also from the scientific outputs of this project. So we had initially planned for 2 hackathons, one to be organized by UPB Edina's team from Romania, and the second by Teltech from Estonia, and both these hackathons have been completed. we have planned for 2 summer schools. One was organized by BME Hungary last year, and then sorry, not last year, this year actually. And then the second summer school is planned for next year by TUC Germany. So this is an upcoming event which you can keep an eye on our website and our social media platforms. And as and when we announce this, please consider enrolling for it. I am sure that it will be worth the experience. Now also we have planned for a couple of innovation workshops. One was organized by Innova Plus, our Portuguese partner, earlier. And the second innovation workshop is planned for the next year, which is likely to happen somewhere around May or June. So again, please keep an eye on the possible participation opportunities and look into the possibilities of joining these events, because we will now be showcasing our final results, which will be ready by then, which includes algorithms, technology solutions, some data sets, and of course the usual scientific frameworks and research papers and the outputs from test and TIS activities, which includes some high TRL level applications as well. So that's all from my end on the introduction of ENFIELD. And now I hand over you to Olivier and Agina before you dive deep into these technical and scientific aspects of AI agents. Thank you. And in case if you have any questions on the general areas of ENFIELD or any basic questions, please feel free to shoot.
Thank you, Pankaj. Yes, Jaime, you have one question.
Yes, thank you for the presentation, Pankaj. I was wondering if these calls for the PhD students or postdocs are restricted to the institutions or the countries that are in the consortium, meaning somebody from Brazil can apply for it from our university, for instance?
So in this particular case, the calls were open to anybody and everybody minus the consortium partners. So anybody coming from Horizon countries or Horizon associated countries was welcome to apply for these open calls. But like I said, that we had planned for 4 open calls and we have concluded all the 4 calls. So the researchers selected under the 4th call will be starting from January next year. So unfortunately, there are no more opportunities to apply for tests anymore. But in terms of eligibility, yes, anybody associated with Horizon countries or associated countries was eligible, minus the consortium partners.
Okay, thank you.
Thank you.
Thank you. So if we don't have any more questions, thank you, Pankaj. And we will start the first session with the first presentation by Jaime Sichman, who is professor at USP Brazil. Then we will have Gauthier Picard from Onera, France. Then Alessandro Ricci from Unibo, University of Bologna, Italy. And Alessandro Sorici from UPB, Romania. So the idea is to, as I said, to introduce and to connect multi-agent systems, this quite old fields of research in AI with agentic AI and LLM, what is currently developed in the AI domain. So, Jaime, the floor is yours. I'll let you share your slides.
Let me try to do it. Share.
So while you are sharing your slides. So we have 20 minutes of presentations and 5 minutes of short questions related to the presentation. If you have more general questions, please keep them. We will discuss them at the end of the session. Okay.
Need permission to share your screen. Maybe I can send you the PDF, Olivier.
Yes, but I don't
because
see
it's not working. Wait, just a minute. I don't know what's happening here. It's because I just changed the computer and I deinstalled the Teams. Sorry for that.
So send me your slide. Yes. So if you want to ask more questions about ENFIELD, this is the time to ask these questions. Please feel free to do. Otherwise, you can.
Got it?
Wait.
It's crossing the ocean.
Yes. I think that the main point is crossing.
What?
By institution.
Yes.
So you send it by email, in the chat of Teams, or how? Probably not in the chat of Teams because you are outside the institution.
Yeah.
Okay, that's it. Have it. Wait.
Sorry for that.
Okay, let's go.
This is precisely what we want that trustworthy AI don't do. To avoid people to share things when they want to share things.
Wait. So this is here. Tac, tac. Wait. While to off. Okay, that's it. Okay, finally, I will do it. So I think that you see the slides.
Yes.
Is that okay? Okay, so
Let's
start.
go. Okay.
Yes.
So good morning, everybody. For those who don't know me, my name is Jaime Sichman. I'm a professor at the Scuola Politecnica, which is the engineering school of USP, University of São Paulo. Our university is the biggest one in the South Hemisphere and the first one best classified in all world rankings. And I'm glad to share with you some thoughts about the research journey of multi-agent systems from the very beginnings on distributed AI just to reach to agentic AI. Next, please, Olivier. So the outline I prepared is just to make a small introduction of what we consider of being agent and multi-agent systems. I think that everybody knows that, but I want to stress some points that I think that are particularly important for the community that has been studying this and not the community that is appropriating the labels that have been created in this community. And then I'll show you a roadmap of the YAMAS conference of workshops that were happened so far, stressing their main topics of interest. And then I'll conclude trying to make the link with the agentic AI for what Olivier has asked me to do. Next, please. So let's start with the beginning. So for those who don't know these guys, these are the guys that organize not a webinar, it was a presential workshop in Dartmouth College in 55. There are McCarthy, Minsky, Shannon, etc. And we could wonder in what these guys were interested in, right? So there are different, I think it was a very particular moment in history where brilliant people were put together in order to, let us say, leverage the knowledge of a certain domain. For instance, Shannon worked a lot in cryptography and security and transmission of circuits. Neil, you know well. John McCarthy was already a logician, and so on and so forth. Next, Olivier. Okay, but what happened at that time? Each of the, let us say, research interested were studied alone, right? So there are people that were interested in AI search. There are people interested in knowledge representation and reasoning, in perception, in planning, and in natural language processing. And what happened is that these people didn't speak to one another. And it's something I think it's quite similar. I wanted to put this light of what is happening today, right? Because there are people in agentic AI or LLMs or some areas that do not cross the border. The problem of being very narrow in your subject topic and don't have to flourish new ideas by the intersection of new ideas. So there was a lacking paradigm to unify this. Next, Olivier, please. And this lacking paradigm, in my point of view, wrongly people attribute to Russell and Norvig, right? I think everybody of you that have studied AI in the university, you use this book. This was the first edition, right? And where they introduced in a brilliant way the notion of agent as being a unifying paradigm, okay? And why I tell you this is wrong? Next, Olivier, please. Because almost 20 years before the release of this book, there was already a community of researchers that were interested in how these paradigms could be integrated in order to solve complex problems. And these entities were called intelligent entities or agent, and the stress was how they could coordinate themselves in order to solve difficult problems. And in the first wave, let us say like that, the interest was more focused in the problem itself and not the architecture or to give some models or how can I say models, yes, models to guide the cooperation, the coordination. The issue was to solve the problem, right? And this was called distributed problem solving. At the same time, some other researchers that were around and said, oh, okay, you have this agent solving this problem, this agent can do planning more, and this agent can do perception more. How could they change, and how we could orchestrate them in order to solve difficult problems, not that didn't arise beforehand, right? So this would emerge, and this was called multi-agent systems. And both of them, in the beginning of the field, were put together in a same label called distributed AI. Next, Olivier, please. So I stress this comment of Nick Jennings, Katja Sikari, and Michael Woodridge because I think that the issue of complex software systems is very important to the field of multi-agent systems, right? So we don't build them just for fun. We build them because we believe that other techniques are not sufficient to design, to implement complex software systems. And in order to do so, we need to be influenced by theories and by the ideas of other areas, both from computer science, like distributed systems, because the agents were distributed, how to program and make software engineering, but also of other areas like social sciences, economy, management, because these give us clues of how a general entity of this could behave. Next, Olivier, please. So an agent in this kind is I think everybody knows, but I want to stress some points. Real virtual autonomous entity, which is proactive. He seeks for goals, reactive. He sees what happens in the environment and reacts accordingly. Social, he interacts. The social is very important. And all of them exhibit organized activity. This is very important also. I mean, you don't program each of them in isolation, right? By eventually interacting with the users. Next, Olivier. And then, in order to do so, each of these agents must reason. So there are capabilities of reasoning and formal reasoning to decide and to learn, both about the domain. So this was the application. So this part was the first one studied in distributed problem solving, but also to reason, decide, and learn in the social and organizational stances. Meaning, this guy sent me a message. Should I respond to it? Like us nowadays that we receive a phone call, right? And most of them are fake calls, right? Organizational reasoning. Should I do this job? Should I accept to do this task? Seemingly, we do this all the time. We learn, we decide, and we elaborate on these issues. So what I put in red is that the specific interest of the multi-agent system community regarding this collective definition is precisely this social and organizational stances. And this I will be in the end concluding for you. That is what we believe that nowadays lacks in agentic AI. Next, Olivier, please. So a multi-agent system is a collection of these entities where there are resources. They can have control on these resources, and you can have a plenty of these societies or systems that are evolving at the same time. So think of what is happening today if you have a lot of agentic AIs with ChatGPT and others from the other company, or like Gemini or others, etc. So you wouldn't consider that they belong to the same space. They can be divided in different spaces. Next, Olivier, please. So to give a setup and a history of the field, what I say in the beginning that this term of agent and intelligent agent was long before Russell and Over's book. This area of distributed AI, precisely distributed problem solving, was born in the 70s, right? So you have here the actor model proposed by Carl Ewing, the hearsay Q system, which introduces the blackboard model, which was divided to solve the problem of speech understanding. So think of this. Nowadays, the issue is to speak to an iPhone, and the iPhone, by LLMs, etc., needs to give us some answers. This speech problem was studied 50 years ago by these guys, right? With different technologies, different ideas, but obviously the technology was not the same. The results was different, but we have nice ideas there. And now there are Society of Man or the contract net protocol for those that know it, how agents negotiate and so on and so forth. Next, Olivier, please. So in order to give a panorama of the academic field, and this is what I most wanted to do in this talk, at this very beginning, there are three communities that are working separately, precisely in this complex system problem solving, right? One was in the United States, and this community created a national workshop that was called the AI Workshop, which is in green in the left of the figure for you. There were 7 of these workshops that were organized in the 80s, right? So this is how science evolves, right? In the 70s, the community has started to tackle problems, and then the conference or the workshop appeared a bit after. Names of this that I can remember, sorry for those that I don't mention. There was Victor Lesser, Michael Hoons, Les Gasser, that has already passed away, and so on and so forth. In Europe, at the same time, there was a community also studying these issues, and was led by Yves de Mazot, by Cristiano Castelfranchi, by I think some people in Germany. If you help me, Olivier, I don't remember the names now. And then they created a workshop called MAMAO, that the acronym seems weird, but means Modeling Autonomous Agent in a Multi-Agent World. And this was a workshop that happened for quite 10 years, also beginning in the 90s, and there were some books published like that. And the third one, which is not represented there, because I didn't find the figure, was the Japanese community. The Japanese community was very interested in studying this problem too, but with a different point of view, mostly in parallel computing, how this could negotiate and work together in parallel environment, distributed environments, and in optimization. So these three communities, the European, the American, and the Japanese, they linked together and created a conference in the mid-90s that was called ICMAS, which is the third one in the slide, which means International Conference of Multi-Agent Systems. So this community was interested mostly in the red stuff that I show you in the last slides, right? How to engineer, model, and implement the interaction, the organization, and not the entities themselves, but what we could wrap around these entities to make them evolve in a world of these agents. At the same time, there were two other communities that were arising, so the thing was flourished, and this was in the 90s, and these ones in the 90s were at the same time of after Norvig and Russell's book, right? Whose focus was in the entity, in the agent itself, meaning that, well, if you wrap them and if they need to work in conjunction with others, how each of these elements should be composed of, or how we could program them, and so on and so forth. So one community, let us say that both one of them is mostly American, but there were people in Europe, especially in the UK and Spain and Portugal, involved with them. That was called the Autonomous Agents Conference, the Autonomous Agent Community. And they have the life of these was 5 years, more or less, from mid-90s to the beginning of the new century, now our century. And some other researchers that were interested in how we could program these agents more particularly, and which was their architecture, their theories underlying in the language. That was the called ATAO workshop, right? Names of the ATAO workshop that came into my mind are Mike Woodridge, Nick Jennings, and from the autonomous agents, we have Katia Sicara, we have Maria Gini, and people, Carl Sierra, I think, that was a bit late in Europe, right? So at the end, people came together and say, well, we are seeing how an element is done and how the conjunction of elements, why don't we fusionate? And then it came AMAS. The AMAS conference, right, was the joint activity of these three conferences that started in 2002 in Bologna. And in a curious way, I don't know how many of you have been in Bologna 3 weeks ago. The ECAI, the European Conference of AI, was held there. And the gala dinner was in the same room that the AMAS 2002 was organized, the gala dinner. But this is just a moment. So AMAS evolved and have several editions of the conference, and now I put the ones that I were more involved when I was a program chair in Budapest in 2009, and when I organized a conference here in South America for the first time in 2017. Next, Olivier. So what was and what is the research agenda of the MAS community, of this MAS conference that they have a journal associated, which is the Autonomous Agent and Multi-Agent System journal, and also the IJAOS, the International Journals of Agent-Oriented Software Engineering, and so on. So these are the, let us say, the subjects that are perennial, that have been used with more or less interest along these years. Learning adaptation, right? That followed the boom of machine learning, especially in the last 10 years. Game theory and economic paradigms, that was always there. Coordination, organization, institutional norms and ethics, the COINE. Search, optimization, planning and scheduling. Representation, perception and reasoning. Engineering these systems. Modeling, simulation of societies, and here you have the human in the loop. What is a human AI? What the human in the loop? Human-agent interaction, robotics, and innovative applications. Next, Olivier, please. So I'll give you a brief look of the conferences, right? So if you see here in this slide, the first conference was in Bologna in 2002. This year was the 24th that was organized in Detroit in USA. And normally we have one conference in Europe, one in the Americas, and the other in what is called the rest of the world, which is the world without Europe and Americas, right? Next. So let's see the first one. I wanted, when Olivier invited me to do this, I said, well, it would be interesting to see how are the invited talks, for instance, and what were the sessions and how many papers there were in each session of the universities, of the occurrence of the conference. Next, Olivier. So in Bologna, right? If you see there, the plenary talks were about coordination, first one, right? For those who know GP GP was partial global planning, a paradigm that was developed by Ed Durfee and Vitor Lesser, and about, look, agents supporting human and organizations. Right? It is very interesting that the subject of an invited talk of a first conference that was held quite 25 years ago, it's still an open question, right? Because what we are questioning today in our communities is responsible AI, how AI should support. We're not using the name agent, but the underlying idea is that AI is embodied in some agents, right? This was the plenary talk. And we have all other invited talks about psychology, about planning execution, and about robots. You see the guys from Japan. This was a community that was always there in AMAS with some fluctuation, more or less. But the idea was focus, as I said in the beginning, the original in the red, the main interest is in teams of robots, right? Not how you organize one robot, but how these teams can coordinate. Next. In 2009, quite 10 years after, in Budapest, right? Next. The invited talks were Mike Hunes, which is from DPS to MAS, continuing the trend. So the idea is that these two lines of thinking of the systems in isolation to see what they can provide, or having a problem, try to build a multi-agent system to solve it, are going to converge. Klaus Troijes that talked about agent-based simulation. And here I want to open a parenthesis. There is a huge community in Europe called ESSA, European Social Simulation Association, which is composed of sociologists and people from political science that use simulation, and in particular agent-based simulation, to do that, right? And this community was a bit a spin-off of some AMAS workshops and AMAS communities that I will show you later. And Manuela Veloso that presented something about the robots. Next, Olivier. In São Paulo, next. Our invited talks were about also simulation. You see there Ana Bazin with for traffic, and especially Jeff Snyder that was in the Carnegie Mellon, but had just moved to Uber in that time, about self-driving cars. So the operationalization of autonomous agents and how do they deal together in a road, for instance. And Julie Shah about human and intelligent machine teammates, right? So this trend of having a research of how human interact with these agents has been always important. Next, Olivier. And the two last ones, in Auckland, in New Zealand, we have a talk on engineering multi-agent systems and see how this evolves over the 30 years, about reinforcement learning. And reinforcement learning has been, there is an acronym, multi-agent reinforcement learning. We have lots and lots of papers of these in the last 10 years. And agent and humans of Liz Sonnenberg. Next, Olivier. And finally, in Detroit, the last one that happened this May. Next. We had the idea of how multi-agent system can replicate the complexity of human cognition and social behavior. She works in Ann Arbor, this professor. And this is very interesting, as today we are ascribing this property to this agentic AI teammates and so on and so forth, or LLMs, right? Not the agentic AI themselves. Jeff Rosenstein, that was retiring, he was one of the fathers of the community, and talk about the appropriate foundations of the field, especially the economic-based line of research. And Virginia Dignum that presented something about responsible AI and autonomous agents and how these are related. Next, Olivier. So just to have a look at this last conference, you see that This is the program, right? How the sessions were organized. We don't have explicitly the name LLMs or the name agentic AI inside. We had some papers that I'll conclude in the end that were in some of these sessions dealing with one of the problems, right? For instance, if I want to communicate with the user how the agentic AI does, how if we are about reasoning and planning, how we could enhance planning in this agentic AI and so on and so forth. Next. So I want just to stress that for these 24 years, there are lots of communities that were built inside AMAS themselves and that have organized workshops. And this one, some of them, some workshops arise and disappear, but others are long-standing ones. And long-standing ones means that, first of all, there is a bank of people interested in this topic, and then eventually they became a trend of the whole conference, right? So here you have, for instance, the optimization and learning that has been there quite forever. First, there was a workshop on optimization and another on learning, and then they fusioned, especially when there was a boom on the reinforcement learning, multi-agent reinforcement learning. The last 10 years, approximately, when this issue of responsible AI and explainable AI was in the trend, there were some workshops that were created by that, as well as the workshop on agent for social good. Next. But I would stress 3 workshops that are very, very long-standing. The one on multi-agent based, yes?
Could you please try to close
yes,
your...
Yes. Okay. I'm just getting to the end. The multi-agent based simulation, who has his 26th edition this year, and that was created with ICMAS before Autonomous Agent. Next.
Sorry.
The agent organization, where you have the COINI, the Coordination Organization Institution Norms and Agent Systems, that is in the 29th edition in this year. Here they have a parenthesis because this workshop organized not only in AMAS, but you have parallel editions of the workshop in IGCAI, ECAI, and other conferences. Next. And finally, the engineering mass community, which is the EMAS workshop that has the 13th edition in 2025. Next. So to conclude, next. We have research topics that had appeared and disappeared in these 24 editions, like believable agents, agent communication language that wasn't an issue in the beginning, and after FIPA there was not, right? Protocols, middle agents. Others dealing with coordination, game theoretic models, social choice, simulation are always there, engineering, optimization, right? And I want here to stress the hype, right? In 2024, which is in Auckland, where I was one of the general chairs, we had 3 papers that has the word LLM in their title. In this year, we have 13, right? So people were not talking about agentic AI, but were talking about LLMs, perhaps because they think that agentic AI must improve in order to get the characteristic that we want in this community. For responsible agents, etc., we have from 1 to 4. And agentic AI, the term itself, we didn't have any paper with this in the title in 2024, and 1 in this year. Next. So I would conclude that warning you to send papers to AMAS 2026. For the workshop, sorry, but the submissions for next year is just finished. And we will have a big celebration of 25 years because it's the 25th year of the community. And I'd like Olivier to thank him the opportunity to put this together because probably I'll use part of these slides in the conference next year. Next. So I conclude and thank you for the attention and I'm open to questions.
Thank you, Jaime. We have time for one or two questions, very short questions if necessary. Otherwise, we can wait for the end of the session so that we can have some discussions. Is there some question? No. Okay. So thanks, Jaime. I think that we will discuss all this at the end of the session. So the next speaker is Gauthier Picard, who will provide us with a quite good overview of a coordination multi-agent systems focusing on optimization. So the floor is yours, Gauthier.
Yeah, can you see my screen?
Yes.
Yes, is it fine? Okay. So thank you for the invitation. I'm very pleased to participate today. I'm very pleased to pass after Jaime because as part of some concepts I need to discuss today have been introduced by Jaime. That's perfect. So yes, I will kind of narrow down the perspective around multi-agent optimization, which is kind of part of distributed problem solving and cooperative problem solving that we address for a long time in the multi-agent system community. So excuse me. Okay, so what is multi-agent optimization? So multi-agent optimization, of course, is dealing with agents, multi-agents, distributed artificial intelligence. So Jaime did the work about introducing this concept and the history of this, all these concepts that are came for a long time ago now. Putting agents into agentic AI into this perspective is a way to join the efforts that have been done for now 50 years and more, and now with new ways of maybe modeling or solving part of the sub-problems that we identified many years ago. And especially when we are dealing with the autonomy, the interactiveness of the agents, how we interact, and of course, the introduction of chatbots and very powerful chatbots is a way to improve the different interaction models and the modalities that we had so far. So let's back to Russell and Norvig that Jaime mentioned. They didn't discover or invent or the agent concept, but they provided a very good look at how to conceptualize the agents and the architectures and all the different submodels that are necessary for agents to reason and to act on the environment. So I will specifically focus on the utility-based agents because the optimization perspective is about optimizing some function, and most of the time is related to some utility that the agents are computing or that agents are wishing to maximize, for instance. So in their book, Russell and Norvig propose several ways of looking at the architecture of agents, from the very simple reactive agents to more learning agents. And in the middle, you have kind of utility-based, model-based agents, where the agents are perceiving the world through sensors. They can make a model of the world to try to grasp what the world is like now, so that they can predict what will be the consequence of their actions, depending on the state of the world and their own capacity and their states. And then depending on the utility function they have, they will go, they will attempt to act so that the environment will go into a more favorable state that will maximize their utility. So this is what is called the utility-based agent. Of course, part of this subcomponent of the agent can be learned. For instance, the model of the world might not be known a priori, but could be learned, like, for instance, like the most subtle world models that are today developed in the agentic AI world. Or it could be any other subpart of the system that can be learned. For instance, the utility function can be learned. You can learn the set of action. You can learn the constraints. Many things that guides the agent can be learned. And this is a very interesting perspective today. So, but when we are dealing with optimization, we are dealing with decision making. Agents have to make decisions and to take actions. So what is making a decision in our case is, for instance, deciding what will be the value of a decision variable if we stay in the optimization world or the satisfaction world. So this decision can be mono agents. For instance, the value of the variable is satisfying one agent. So this variable could be, for instance, what will be my next destination, what will be my color, what will be the next proposal I will do during an auction. So many kind of decision could be considered. But of course, in the multi-agent world, if you take a decision, if you make a decision, you need to consider the other agents into your decision frame. So that means that maybe you want that your decision is done with the agreement of the other agents if you are cooperative, or maybe you want to arm the other agents, but whatever the case, you want to make your decision depending on the other agents. So how can your agents make their decision in an autonomous and coordinated manner? This is what we call cooperative decentralized decision making, and you have different ways of making this decision making. Mostly the idea is that you want your system to find a best joint state. That means all the agents to find the values of their variable, of their decisions, in a coordinated way. Most of the time, you want also to be cooperative. That means that you want your agents to behave like a team, no competition. For instance, if you are considering a team of robots that need to explore an unknown environment, you want them to be as cooperative as possible so that they maximize the coverage of the exploration. So you want to maximize the global utility or minimize the costs of these joint actions. And of course, some agents may have their own beliefs, their own utility, but in the end, they will act with the other agents to reach a common goal. So why do you decentralize? What would you consider coordinating multiple agents? The first one is, for instance, for scalability. Using different agents, concurrent agents, is a way to avoid bottlenecks, for instance. Or maybe you want to guarantee some privacy. That means that if you consider that the agents are human representative, that take charge of the agenda of each human participant, maybe you want to coordinate and to find a time slot for the next meeting, but you don't want to disclose all your information. And so in this case, you need to coordinate. You want to cooperate to have reach a common goal, for instance, a common time slot, but you don't want to disclose all your information. And at some point, you may also want to decentralize to provide robustness to your system so that if one agent fails, the other agents will be able to adapt and to reallocate maybe the task of the things to do and to keep the system working. Examples of systems in real life are, for instance, robotic systems, swarms of robots, where you are in search and rescue mission coverage, where you want your agents to coordinate, to find victims, to explore the environment as efficiently as possible, and with it could be heterogeneous fleets like we seen on this photo. We also consider, for instance, in my lab, coordinating constellations of satellites, where you want the constellations or the stakeholders of the constellations to coordinate to improve the efficiency of the whole system. You know also all the warehouse logistics robots like you can find at Amazon or other warehouses, where you want your robots to avoid congestions when looking for parcels, for instance. Okay. And the human into all this, of course, it's not just a bystander. It could be a supervisor that will set the higher level goals that the agents wants to achieve, or they can set the constraints, the mission parameters for your robots. It could also be a teammate that actively participates to the task, like in human-robot assembly or human-robot cooperation. It could also be a constraint source. That means that the human preferences need to be elicited so that the system can understand where the human wants to go. And so, of course, you need interactions to do that. So I will focus on two kind of models and algorithms that are used in distributed problem solving and multi-agent optimization. The one is distributed constraint optimization, or distributed constraint reasoning, where you have a set of agents that communicate to assign values to variables. That means that interacts to find joint states and to decide in a collective manner. And these interactions are constrained by the real constraints of the optimization problems. So most of the time, as I show here on this figure, you will explicitly represent the interactions of the agents using the structure of the optimization problems you are tackling. So that means that depending on the structure of the constraint program you want to solve, the agents will interact in a different manner. So in this case, you have agents that cooperate depending on the structure of your problem. On the other side, you have auctions approaches or market-based approaches, where you will use the metaphoric approach of using auctions, where you have an auctioneer that proposes items to sell to a set of bidders that will evaluate the different items or the set of items and will bid on them, so that the auctioneer can decide who will win which items. So this scheme is used a lot in resource allocation, in task allocation, to coordinate, for instance, robots. It is very efficient, and it mimics economic markets to achieve efficiency. For both approaches, many algorithms and approach exist. So I won't go into the literature for this. I gave you some pointers in the slides that you can dig if you want. So let's now go a little further into the human perspective, into this kind of system. So as I said, you have different human integration strategies. The first one is to consider how the human can be integrated into the system when you need runtime elicitation. That means that most of the systems are dynamics, and the preference and the constraints are not static. That means you need to adapt. And most of the time, this is the human that knows that. So the system must elicit human preferences in real time and adapting the criteria dynamically. So for the distributed constraint optimization, that would be, for instance, the preferences for time slots in an agenda that may depend on the time, on the day, or maybe the health of the human user. So that means that the system, before making some decision, needs to interact with the human to elicit the preferences or the constraints. Another way of integrating, the human in the system is to consider the human as an agent, as the other ones. That means if you're in auction, maybe you will have artificial agents and human bidders that will bid on the same items, on the same system, or maybe you can consider that the agents can influence the bids of the agents when they are coordinating to acquire items in some auctions. And you also have what is called mixed initiative. That means that you will share the way of solving a problem between humans and robots. You want them to work end to end in a collaborative strategy where the human and the agents are more or less keep getting the control of the solving process And depending on who is the best for solving or for reaching the goals, the decision will come to the human or to the robots, or maybe both. So this is a very large piece of literature here. So here again, you have some seminal work on human-as agents, on mixed initiatives, and runtime elicitation. Have a look to this as very starting points, either in the looking at the, for instance, at the different work that cites Bradshaw's work on human-as agents, but you can look at Tabaki on runtime elicitation and the different papers that they cite in here to get a wider perspective on all these human integration strategies. So here is an example, for instance, in auctions, that are work that we are doing in collective robotics, where you are considering what is called bid intersection. That means that you have an operator that can bid like any other agents using exactly the same protocol, so that, for instance, in this auction that are decentralized auction without an auctioneer, but that are based on consensus, the robots are not changing their protocol at all, and the human can see exactly the same information as the robots and interact in a seamless way with the robots and the protocol, so that we can keep the very same convergence guarantee or quality guarantee that you have in this kind of protocols. So the user can either let the system do what he wants, so he lets the robots acting fully autonomously, but maybe at some point, so the agents here are these UAVs that have been assigned some tasks. They decided to, in the decentralized way, to assign to the different tasks that are these red crosses, depending on the distance, on their plan, and many other considerations. But at some point, maybe the operator sees something that the robots cannot see. For instance, there is a fire somewhere, or maybe he knows that a task that an agent identified has been misclassified, and that the robot won't be relevant for performing some task. So maybe the user will bid for the agents so that they lose some of the task or win other ones, to help them reaching a more efficient allocation. And if we go at the full right side of the spectrum, of course, the operator maybe can decide for all the agents if he wants, because what we want in such case is that the human operator always have the last word, of course, because we are looking at critical systems. So autonomy is used because you want to avoid to deploy your fleet very quickly and let them as autonomous as they can. But at some point, you want to keep the control, and if you want to take the control, you need to have ways of doing that. To finish into a more prospective perspective, let's look at what about multi-agent optimization in the age of large models, like large action models or large language models, and looking at how can we go to multiple LLMs coordinations. So if we look at the DCOP perspective and the DCOP models, where you want agents to make decisions depending on constraints that are interlinked, there are several works looking at how to use DCOPs for LLMs. That means you have several LLMs that are providing some outputs, and you want to use DCOPs to manage the output of multiple LLM agents to optimize their joint responses and alignment. If you want to, for instance, to help the LLMs to provide outputs that are consistent, even if you are using multiple agents to answer your questions. So there are some work on this. The other way around is to consider LLMs for DCOPs. That means you don't use DCOPs to control LLMs, but you use LLMs for solving part of the DCOPs. That means that you are leveraging the reasoning capabilities of LLMs to formulate some constraints from natural language into a more formal language that can be understood by the DCOP solvers, and to act or to act as heuristic solvers, that you are using the reasoning capability of an LLM to solve some part of the problem. Maybe, for instance, only a sub-part of the problem for a robot, only to ask the LLM what would be the right order to make these tasks. The LLM will use maybe some kind of heuristic reasoning that will not be an optimal reasoning, but it is sufficient enough for helping your system to coordinate. So there are works too, very recent works from 2025 about these two topics. It's only part of work that exists. It's a very dynamic domain here. Now, if you look at auctions, you can consider LLM agents as economic agents, where they can interpret the auction context, okay, the price, what are the other stakeholders, the other bidders, and all this stuff, and formulate strategies in natural language games. So there are many works on this. They are very recent too. So I cite two. You can look at four other ones in the slides. But you still have some problems here, is that LLM agents, so some part of this research demonstrate that LLM agents spontaneously learn to collude to maximize collective reward. So that means that depending on the type of auction you are looking for, if you are fully cooperative, it's fine, but maybe in some other competitive ones, the collusion could be a problem. And the thing is that it's even without explicit instruction. And most of the time it's due because they have been trained in the same way, and in the end, they are the same data set, and they are spontaneously try to make the same decision, and maybe to collude or to coordinate, which is a very interesting topic in the mechanism design domain, where you have kind of new challenge of designing LLM-proof auctions that are robust to this kind of tacit collusions. So it's very interesting way of looking at LLMs as auctioneers, as bidders, sorry. So to conclude, I've been maybe a little bit fast, but I would be happy to answer your questions, is that, of course, the challenge and opportunities here are lying in the synergy between kind of classical multi-agent models, like DCOPS, auction, all this stuff, and the generative agency stuff that we are all experiencing today. So, but still, the contemporary discourse on agentic AI is kind of amnesiac, lacking maybe the history and the background, for instance, that Jaime provided us just before, about what has been on multi-agent system community for 50 years now. And we are dealing with very engineered architectures that are tailored to very specific and the quirks of current models. So what if we change the model, or we upgrade the model from GPT 5.0 to any subsequent version? Okay. The problem is that it's very, let's say, technophiliac and not looking at what has been done in the model world. So in reinterpreting agent and multi-agent contribution in the age of agentic AI is a very good idea. The point is that we still need to look at 50 years of active research, not to reinventing the wheel. And these grounding models in this history that has been developed many years by very talented researchers with very good results that has been applied in many fields are as many opportunities to improve the use of large models. So this is one point. And the other point is that, of course, large model can serve as new bricks to augment the agents that we are building, or the multi-agent systems, or some bricks, subcomponents of the agents that we need to, for instance, bidding functions for bidders. It could be planning bricks for robots. It could be interaction bricks when you want to interact or to send messages or knowledge to other agents. So many ways of augmented classical agents with these large models. And that's all for me. I would be happy to answer any of your questions.
Thank you, Gauthier, for this very interesting talk that complement what Jaime introduced before. So there is a question in the chat, but that maybe Gauthier, you can answer in the chat for these specific questions. This way we can continue to build the global landscape with the presentation of Alessandro. Then at the end, we will discuss the quite difficult questions that you raise at the end of your talk. If it's okay for everyone, there is no question. So please, for the participants, ask questions in the chat so that the presenters can answer them during the presentation of the next one. Thanks, Gauthier. Alessandro, the floor is yours.
Yeah, do you hear me?
Yes, perfectly.
Okay. Thank you for inviting me. And now I try to, yes, you should see my screen. Do you see it? So first of all, thanks a lot for inviting me to do this kind of talk. I'm not sure what was the talk supposed to do, but I'm share my reflections or mumbling about across software engineering. And so my background is agent and multi-agent system mostly from a software engineering perspective, or seeing agents as a paradigm for developing or designing things about software systems. And I take this opportunity to share some points about what is happening from my perspective. Unfortunately, I missed the Jaime the seminar because I was with the kids, but I guess that I hope that to join in a good way. So the title is on the need for a cognitive hourglass for human compatible agent for human compatible agent based AI. So what's the idea? So yeah, as you know, maybe this was shared also by Jaime. I learned that from Gartner that 2025 is the year of agents. Well, I was very, very happy because it's 3 decades that we are working on agents. But I discovered that was not the agents that we are working on, or it's more complex. Of course, it's about agentic AI, but in a very pervasive, and from my perspective, it's my opinion, has never happened before. So what is happening? Well, we have this new class of agents, language agents, also called LLM-based autonomous agents or generative agents, that are not LLMs. First of all, it's good to put maybe also Jaime already told this, but it's not about LLMs are not agents, are just input-output system LLMs. The point is that what happens when you put this kind of a nice input-output system inside an agent, so an agent architecture that is able to observe and act upon the environment using the natural language as a way to represent things. And this is taken from a wonderful paper for me, very inspiring and brilliant, called Cognitive Architecture for Language Agents. That say, okay, that was the beginning. So nowadays we have more and more articulated architecture about language agents. They talk about cognitive language agents, in which you don't have only the LLM, you have also some memory, you have also other things that we call about cognitive language agents. And so that's the year of these kind of things. So Gartner and all the many industries are celebrating these AI agents and agentic AI. And according to Google, these are systems that accomplish a specific goal with limited supervision. So this is quite compatible with our notion of agents and multi-agent system. And they say, okay, and agentic AI, as Jaime probably already discussed, it works by using AI agents. It's more workflow oriented, but indeed they are focusing on autonomy. So they talk about autonomous entities. And here in our community, as also Gauthier said, and also Jaime said, the notion of autonomy has been explored deeply from Cristiano Castelfranchi to all the guys that have been. But indeed, the concept of autonomy that we found in this kind of agency is not that far, because the idea is that to perform tasks without the constant human oversight, maintaining long-term, I'm reading what Google says, you say, but Google is like to say all the companies that are providing already technologies to build these kind of things, maintaining long-term goals, managing multi-step problem solving. So this is quite near, at least for me, or the idea of autonomy that we had. And in fact, if I get into the architecture of these AI agents that are coming up, it's not so far from our, for instance, BDI agents. So we have a component for planning, for the memory, the action. We have also the environment. I was working a lot on the environment and abstraction for first-class abstraction for the environment, that they talk about the essential of tools. These agents need tools in order to be able to do things, also to support their activity. And they also do this kind of reflection on these kind of things. Indeed, they are using different techniques based on prompt engineering and all the kind of approaches that have been developed so quickly in that context. So not the classic one. And indeed, also the cycle, how they works, well, it's not so from my perspective, that they are very near to what we are exploring for years about what does it mean to have a reasoning cycle. So there is perception. So these are agentic AI starts gathering information about surroundings for different sources through sensors, databases, and tools. Then there is the reasoning stage, so that they are using LLMs in order to understand the context, identify relevant information, and identify possible solution. Then also establishing plans, so using LLMs for doing this, setting goals, also breaking down then into smaller steps. So all these kind of things have been are absolutely interesting. For instance, also for the researchers that were doing agent programming and multi-agent programming. And they are able to do action based on these plans, so performing tasks through tools. And after taking action, they are able to learn from the results, so understanding what changes. So, and in a continuous cycle, in order to learn and improve over time. And this is part of what they suggest to be normal technology that nowadays is available for building application. But then if we go to programming, which is really something that I love, I see that this kind of programming, so this is, for instance, taken from Google, but there are really all this kind of framework, it seems to me very similar. This is a way to build an agent. So you describe the goal, retrieves the capital city using a specific, this is of course a toy, but just to get the idea, programming means describing the instruction. So you are an helpful agent that provides this capital city as a country using a tool, and blah, blah, blah. And that's it. So this is kind of programming for them, specifying what kind of tools the agents should be used. So this is bringing, in the context of software development, a kind of tsunami. We are moving from the software 1.0, the classic one, to the software 2.0 that was developed given the deep learning, let's say, last decade. So the idea that you don't have to code software because you have that training and learning is used in order to understand how to achieve things. And that kind of path was suggested by Andrei Karpathy. But then nowadays we are moving towards software 3.0, so that we talk about wipe coding, and the idea is to support full-fledged agentic-based software development, so that humans are going to specify a lot, but they don't have to code, they don't have to design, because this is actually part of the job of teams of AI agents. And actually, this is not happening in the research. What is impressing me is that this is happening in tools that are supported to develop application nowadays. So indeed, there is hype, but this is happening. So, since I love my context of agent-oriented software engineering and agent programming, I'm asking myself, what is happening? So is it unuseful what we had done in the past? Well, Cristiano Castelfranchi, as you know, will say, well, look, all this is bringing, I see, some problem, some possible danger of eliminativism. And he was explaining us, to Franco and to me and Stefano Mariani and all the guys that were co-authors of this paper that we published some times ago, that indeed, since we have such a powerful micro-level implementation mechanism, from neural networks to transformers to whatever, the tendency is that we can deem high-level abstraction unnecessary. We are forgetting the importance of defining, even if lower-level mechanisms are so powerful, even if we don't understand fully them. But he was saying, and we were saying this tendency of saying, you don't need no more BDI, you don't need no more this high level of abstraction, because you have this kind of engine that is such incredible. And so it means that, okay, I don't have to have, I can go from writing my application directly on LLM-based generative agents that is capable of doing this without understanding what is in the middle. Again, here, my message that I deeply believe the importance instead of having abstractions and level of abstraction. And so going back, so we need abstraction in order to specify, to understand, explain, predict, control the behavior of complex systems from all levels, from users level, but also from developer levels. And so here I found it absolutely useful to go back to what Alan Newell was saying about the knowledge level. Alan Newell, long times ago, maybe also it was part of the Jaime point, but was introducing this idea that saying that this hierarchy of computer system in which you go from electronic devices and you need to have proper way to understand, to describe system that after all the levels, so that from his point of view, given the complexity of system, the knowledge level is the proper way to describe system. And he came up with the idea that today we would characterize as an agent, but it is characterizing a complex system which is doing in terms of goal, in terms of knowledge, in terms of perception. This is a level of abstraction. And indeed, it is very near to the Dennett's intentional stance too, if you know it, if you see it. That this idea was also extended to the multi-agent organization level by Jennings too. And so the idea is, for me, was a main question, that is still a main question to me. So how to exploit, on the one hand, the generative power of the micro level, data-driven based on deep learning or whatever, language-driven based on LLMs, and that's it, but preserving a proper level of abstraction on the macro level. Because we need, in my opinion, this engine is indeed absolutely powerful, and it is possible to do things that we never have done before in terms of flexibility, in terms of autonomy. But how to preserve the proper level of abstraction that we want to have? Of course, my perspective is in engineering these agents en masse. I don't want to write simply that kind of code like Google is suggesting. So think about that. We were thinking about we need a it could be useful to recall the hourglass model that has been used for the internet. The hourglass, the internet hourglass, is the hourglass that is the blueprint in which we use it to design the internet, that was so good in order to define a waist, a narrow waist, defining the proper abstraction in order to make it possible to have, on the bottom level, a great diversity of supporting technology, and on the top level, a great diversity of applications that could exploit the enabling technology. And so the idea was, to have, in this hourglass model that was for the internet, but it is an architecture in general, useful in general, the key layer is the waist, what you put in the middle, so that the set of abstraction that make it possible to create this connection and allow for openness on bottom and on top. So why not to think about, we said, a cognitive hourglass? So whatever you have, LLMs, wonderful technology on the bottom, but please, we need to set up a cognitive waist which is human-oriented. to build our agent application and our intelligent application. So the idea is that let's think about having a cognitive waste that should be a set of abstractions that could be powerful enough in order to exploit as an effective enabler, to exploit the mechanisms and related theories on the bottom, including generative AI, but at the same time being an abstraction barrier to preserve a human-oriented abstraction level, for designer and also for users. So that the idea is avoid the eliminativism in order by defining together what should be this cognitive waste. Cognitive waste could be useful from the different point of views. It should be useful so it should be indeed at the knowledge level, and it could be useful for enabling to fully exploit the generative power of things that we have at the bottom in order to build application on the top. And so, but also for the user, because the main research question now is, okay, if we have this kind of, if you assume this kind of hourglass, what kind of abstraction, cognitive abstraction we are going to put in the waste that are mediating? It's like to say, what do you put in the IP level in order to exploit all the enabling technologies on the bottom and allow for openness on the top? Well, I would, of course, this is a main research open question, but I would say that we have good, let's say, directions that would get good constraints that we can exploit in order to define this cognitive abstraction, because these waste, this abstraction should be able to support all the abilities that we want from this kind of system. So explainabilities, predictability, controllability, as we have already discussed, and as you will discuss a lot today, but also flexibility, adaptability, the level of autonomy that these new technologies are able to do. So this is my final, maybe I was too quick, but anyway, that was the reflection. So the idea is that we are, in my opinion, really crossing a moment in time in which you can say there was a before and then there is an after that. And it is essential to be back, given this power, all these kind of opportunities, to the proper level of abstraction. So the Alan New's message, and also all the community have done, thinking about these abstractions that are not only, for instance, goals at the individual levels, but I think about the organization level. So norms, so commitments. So I would work a lot in order to define these levels, so that, for instance, I would like my LLM agents, wonderful LLM agents, to talk with the other agents in terms of goals. And also, even if the nice point is that it's not about being symbolic or sub-symbolic, because from a certain point of view, everything will be symbolic. Means we need to have a knowledge level, because we, as humans, we need to understand these kind of things. So this is the main message that, for me, it's very important. Okay, thank you.
Thank you, Alessandro. Do you have some technical questions about the presentation? I think that the final question that you raise at the end of your talk, we will discuss this at the end of the session, if you don't mind. This is a very interesting question, and maybe this is the question that we will ask to the other speakers. Thanks, Alessandro, for this presentation. If there is no question, so the last speaker of the session is Alessandro Ruti. Sorry, Chi, sorry. So the floor is yours, Alessandro.
Yes, thank you, Olivier, for inviting me to give this presentation. Let me quickly screen, and please let me know if you can see it. You should be able to see it.
Yes,
okay.
We can see it. If you could.
Yeah,
yes.
I'm switching
Perfect.
to the presentation.
Perfect.
Okay, so hello everyone. My name is Alexandru Soric, and in the talk that I'm going to give now, I'm going to try to let's say bring the perspectives that have been discussed so far by the previous speakers and ground them into one particular application domain, one that has been of interest to me since my PhD, essentially, that of the umbrella term of ambient intelligence or smart environments in more particular. And there was Gauthier had a nice phrasing at the end of his talk, namely to identify bricks that are to see where these bricks from be they from classical multi-agent systems or from the newer agentic AI perspectives, and place them where they need to be when designing a solution for a particular application domain. And I'm going to try to highlight how I'm thinking, how people think about this, or how a team that I'm coordinating thinks about this with respect to making steps towards goal-driven interactions in such smart environments. I'm going to start by just highlighting why smart environments are such a fruitful application domain where you can have this idea of classical in multi-agent systems, the intelligence of agentic AI that is possible by LLMs, but also human insight comes into play, specifically because in the domain of smart environments, human flexibility and human comfort are essentially boundless. So this little scenario over here is part from of the set of scenarios called the ISTAC scenarios from 21, which were a vision for the ambient intelligence domain for 2010. That was around the year where I started my master's studies, so quite a while back. And in this little scenario, you have a person called Maria who is traveling and then gets to her hotel room, and then the hotel room has to adapt to her personality. And then she can express desires in a goal-driven way, such as wanting to command the bath and to relax after preparing for a presentation, or to adjust the light intensity in the room. What is implicitly said about in this kind of description is that the environment, whatever that environment be, needs to adapt temporarily to the presence of Maria, because this is happening in a hotel. Whatever system or whatever agent Maria is using to interact with that environment needs to actually discover it in a dynamic fashion, because it hasn't been preset. She doesn't necessarily doesn't know what the capabilities of the hotel are beforehand. And the control of the applications happens in a goal-oriented manner. And we can further expand on this, right? Because if you think about the kind of interactions users would want to have, even in such use cases when giving presentations or preparing for presentations, and in conference rooms, in a more, let's say, professional environment, you could have this kind of interaction-driven goals. User environment interactions that are driven by the goals that the user set for themselves, that might not be phrased as explicitly as would be easily understandable by a classical system, let's say. Because users could say it's kind of dark in here to mean that they want more light in the room. You could say keep the room as warm as the living room, this room as warm as the living room while I'm in it. So basically placing constraints on the goal for the duration that has to be determined automatically by the system without the user actually specifying that. And then you could prepare the room for a project meeting, and then you'd say that this needs to figure out which project meeting for what duration, how many people, and so on. So bring in a whole lot of context that exists in the environment and that needs to be understood while treating the scope. And obviously, there's more constraints happening here, because for any of these goals, right, you could have multiple paths for solving depending on exactly the context in the environment. Because if I want to make the room brighter and I have several options to do so, like turning on the lights or actuating blinds if I have blinds for my windows, which one of them is the appropriate one to choose? If it's 4 p.m. on a rainy day, if it's 6 p.m. on a sunny day, what about if the user prefers natural light? Do I actually know about this preference? How will I learn about it if I don't know? And then you can see that when I was saying that flexibility in terms of natural language knows no bounds, This is an example taken from a recent paper that does benchmarking on this kind of scenarios, which says the kitchen feels really dry and my hands are tight. I left the bread rising in the and I'm a bit worried about it. The living room feels dusty. My eyes are itching and my throat is a little raw, like there's grit in the air. So all of this is to say that the user is complaining to the environment that it's not in. There should be more humidity in the kitchen because they're baking something, and there should be a clearer air in the living room because it feels dusty. And so two very small intentions that the environment will need to achieve, but which are phrased in a very, very, let's say, lengthy way that actually has these meanings implicitly. And then again, multiple paths could exist here because you could open a window to solve the case if you can actuate windows, but you can, if you have an air purifier, you can actuate that, and so on. So to summarize what these scenarios introduce is that there are several challenges in this domain of smart environments that can be addressed, can be viewed from the system's perspective that needs to solve for them, as well as from that of the user, which we're going to see in the next slide. From the system's perspective, it is a given that these kind of environments are heterogeneous in capabilities. You can have different things in them, and dynamic in availability. Not all of your things may be available at the same time. All of this means that that the system needs to actually let's say in a lively manner or to at runtime discover these capabilities. So discovery is an important thing. The users may express their goals in a very implicit or let's say under-specified, under-constrained manner. So the system would need to understand the actual intention and even to memorize these preferences from before. The goals that can be expressed can be either things that I want really just to do now, so immediate goals that need solving, or it could be things that I would need to keep running persistently until I explicitly say that I want to cancel them because they no longer apply or I no longer need them. And if I do identify this kind of goals, which are immediate but repeatable, then if I express that need the next time, I would need to have a method by which to match this new request to something that I already did. And maybe I should remember how I solved it previously because that could be applied again. And if there are multiple resolution paths, how do I compare the context of these requests? Because I need to identify if something that I do remember from my previous experience can be applied again because it is exactly the same setup, or if something very similar to. This is one view of, let's say, the technical constraints of what the system has to do, but two other points are very important, namely that even though the devices that I could have, such as the smart light bulbs over here, in my environment, only have one capability, such as turning them on or off, right? That's the only thing you could do. That doesn't mean that they cannot afford more uses, more experiences of use. For example, just turning a light on or off can make the room brighter, right? Obviously, but switching it in a particular on and off in a particular pattern could afford notifications. So it could signal that you have to pay attention to something else. So some capability can have multiple affordances. And then, right, because users will ask people to do different things in repeated manners, whatever I use to solve for that needs to be reusable. So I want it to be reusable. And the need of one user needs not be unique, right? So that means that what I am doing in a particular smart environment, most probably some other person is also in need of. So I could inform the planning that I'm making to solve a particular user's request by my own experience in that environment as a system that handles it, but also based on experience of other environments that have met similar needs. And this is one point that we are actually introducing, let's say, to see if this is a fertile ground for so-called shared community experience. From the user's perspective, the users need to understand what the system is doing. This relates to this notion of explainability and of having a human understandable way of seeing what is being done and why it is being done that way. So we need to have an ability to explain the plan and its effects to the user in a way that the user can understand. Users should be able to tell the system if what the system wants to do is okay, so to validate, but also have a means to teach, basically, because if you have preferences to discuss, then maybe it is the responsibility of humans to come into play and exactly specify the way in which they prefer things done. And if you are to interact with the environment, like in the scenarios we showed earlier, maybe it is the case that you want to be able to start, abandon, resume conversations with the system. So the environment treating system needs to remember things and needs to manage these conversations in the appropriate manner. Now, the next couple of, so my next session of the talk, let's say, would like to bring into focus two main contributions. One from classical, let's say, not the classical, but recent efforts into the instrumentation of environments for multi-agent systems, specifically hypermedia agent environments. And the other is going to look at how agentic AI can play into all the needs, all the challenges that we identified so far. So the first part is why hypermedia agent systems can support smart environments. And this is based on work on hypermedia agent environments. And by hypermedia, basically we have to view, we can take it as the view of the web. But the web doesn't just support web pages, it supports also knowledge bases, it supports messaging, it supports organizational specifications, it supports policies, it supports definitions of protocols for how agents should interact. But last but not least, right, it supports even the existence of things, that can be actuated in an environment, which can have affordances. And this, let's say, higher level overview maps nicely into a conceptual one, going down the idea that Alessandro was highlighting earlier, namely that of abstractions, where you can view this entire ecosystem as a setup where you have agents that will need to interact with it and instrumentation of the environment, of what exists here, as so-called artifacts. So things that can be used to perceive the environment, to to observe it, right? To operate on the environment, to act on it, and to be able to capture events that are generated in the environment. And all of these are considered to be affordances. So basically, this is a mapping, right, of an actual let's say, a web-based hypermedia ecosystem to an abstraction that allows us to actually model each of the things individually, and then even further, right, to express that each thing, if we further look at the actual actuators in the environment, there are specifications from the W3C, such as the Web of Things thing description, which further inform on how the thing itself behaves. Right? What it affords, what inputs and output schemas it supports, how its security is configured, and what protocols are actually used to communicate with the device. So all of this is to show that agents are instrumenting their environment using artifacts, and that they use them to perceive and use, perceiving and using what the active artifacts are affording. This is just a simple example of what this can get to, right? To say that if I have a smart lamp, a hue lamp, it can have a toggle command, which has this way of interacting with it, and it can have a changing of color affordance, action affordance, which can tell it this is the way in which I interact with it, having this kind of input. So all of it is describable. That's the main point. Now, I was saying that we need in this, let's say in the scenario that we were going through, the one main point is for in the system to be able to record experiences of using these devices. There's two ways. The word affordance here means something comes from affordance theory from Donald Norman, which basically relates to the ways that someone, right, the agents, can use a particular object. In this example here that you see, you can, if you have, like, but the idea is to use a door, right, to use a door. But if the door has only a flat plate, then this only affords pushing the door. If the door has a handle, then it affords two things, pulling and pushing on the door to do the same thing, the same intent, opening the door. Now, normally you can say that objects, because of the shape of this flat pad or the shape of the handle, that the objects can give cues, or they can give signifiers. They can signify what the user can do with that particular object. You can then view this, the idea of this signification, from the user's perspective. And this is what we want to do. Basically, from the user's perspective, you're seeing, I'm going to remember that I use this particular capability of a particular thing when I wanted to do something in a given situation. So otherwise said, a signifier will bind an artifact affordance with the intent that an agent has in the context of its execution. And then this, right, can also be presented in a structured form, similar to the RDF one that I was showing earlier. So you can come in, let's say, with standards that exist again at W3C to say that I'm going to represent this in RDF form with context modeling that is, let's say, shackle-based. And then this would look something like this, right? You would have an intent that is expressed in natural language, because we're going to see just in a few moments that we're going to want to match these intents using the brick called an LLM. But then the rest of this can still be understood by an LLM because it is still structured language, right? So RDF is representable as here in turtle syntax, but it's also interpretable at machine level, because you can actually, there are solvers, right, that can check for the condition here that says you should use a toggle, a light switch toggle, if you want to increase the luminosity in your room, but only if it's too low and only if there are people in it, right? If there's more than one person, right? That's when you want to use the light bulb. This is what this is saying. So next part is going to look at why AI agents can support goal-oriented interaction in smart environments. And this is going down to what has been recently observed and what has been highlighted, right, in Alessandro's talk, in Gautier's talk, that LLMs can show potential, actually great potential for at least this kind of shallow or simple planning, for that kind of, even for kind of planning that goes into solving the block sport problem, right, with a lot of blocks. LLMs are still not up to speed for that because they haven't been set up to actually solve just that particular task. But the context in which they were trained on, for which they were trained on, specifically a lot of human knowledge that goes on common daily human activities, right, can lead to this kind of simple planning that is actually useful in an application domain such as ambient intelligence. And this capability is starting to be put to the test. I'm going to show you two examples of this, very recent. One is to test the capability to map from user requests to explicit right, API calls of the devices. So this is the whole test setup. You either want to do it for a single device, so map to the capabilities of a single device, or multiple. That means that the request will require more than one device to actually be achieved. And then there's a further testing done here, namely to detect if the actual request is a valid one, so it can be solved by the environment or not. Because what you would want is not for the LLM to go into that hallucination mode, but rather for the system to actually tell you this is not solvable or you've made a mistake. For example, right, you can see that the requests here, I don't know if they're readable, but the one that I'm highlighting here says, help me set the brightness of the light on the balcony to 50. This would be a single instruction, right, for a single device. For the multiple devices, you could have, I'm going to bed, turn on the air conditioner, adjust its temperature to 25 degrees, and then turn on the aromatherapy. And you see that these are very explicit. So the benchmark itself is for the LLMs or whatever agents are in charge of handling this to specifically match each very explicit intent to a very explicit affordance that is met in the environment. And then there's a simulator that actually evaluates if the system gets it right or not. Another use case then goes one step further and says, well, humans will not only express them in this very different, very exact specifications, right? You could have even implicit or explicit intentions like the one I was showing in the examples at the beginning. You could have just you could just ask about what the environment, what the current environment conditions are. You can even schedule actions in the future, right? So the example given here is saying switch on the kitchen light when the washer is done. So basically that means one thing needs to happen after the other. But again, a showcasing of an invalid one where the system would need to reason that if the user themselves made an error when requesting something, such as it being 6:30 p.m., but then the user saying it's 7 p.m. right now, right? So my guests are coming, make sure you turn on the living room lights. And then the agent shouldn't be complacent in just saying, okay, you're right, so I'm going to reason about this and just turn on the living room light because it's closed, it's 5 minutes and the guests are coming, so I need to turn it on. But rather wait because the user made an incorrect assumption in their request. So the challenge is to identify if this is happening as well, which requires perception of the environment in a correct manner. What I've shown so far are requests that these benchmarks only happen independently. So basically each question or each challenge, each scenario in the benchmark is independent of another. But what, let's say, scenarios I'm interested with a team that I'm working with here at UPB is to create scenarios that are not disbounded from life, right? So in interactions, shouldn't be isolated from each other. They should be repeatable. You should be able to see if you can learn from your past experiences. And maybe because they are the same for you and as well as for some other user, be it by the phrasing or the environment right, the needs are the same, but the phrasing in which you're saying it, the environment and the context are not different. Maybe you should bootstrap from somebody who has experienced this. So what I'm trying to showcase here, right, in this interaction diagram is that the LLM capabilities, you can view them exactly as Cotier's analogy with bricks. They come in a classical role-based split up of understanding the user needs and then explaining the outcome to them. This is where LLMs come into play, to understand that request, because this is something that they're good at, to explain a plan that is abstract or that is framed in a formalized manner, in a natural language way. And then two more things where the planning comes into play, because we've seen that this is what we are highlighting, that LLMs are starting to be good at, this kind of shallow planning. And then the idea is, how do we create examples for them? Well, one could be based on our own experience, the own environment that we're exploring, and the other is based on so-called agent communities. And what I'm going to show in the next two slides, coming towards the end, is that, and starting to discuss on hypotheses that we are making and that we're going to test for in the coming months. Namely, that we want to exploit these systems to their best of their current abilities. And this is not usually the way normally proceed. For example, for planning, you would start, the normal progress would be from something like going from the request to creating an abstract plan and then to instantiating that plan into some executable form, which can have several right, avenues using all the tools that has been described that exist in the currently in the literature for multi-agent systems. The way in which you could use LLM is sort of like a reverse way, but which is exploiting a low cost of opportunity for what currently exists, because these tools have been developed in this way. They have been developed to benefit software developers, as Alessandro was pointing out earlier, that this is happening, right? And this showcases, this is work from 2024, which shows that in a benchmark that evaluates how agents, how these kind of AI agents deal with calling tools to solve different tasks, if you ask them to produce code that solves the tasks, all the models, from the very capable ones, GPT-4, to some that are less, let's say, less performant in terms of the parameter space, such as the Llama 2 over here, it's always the case that generating code solves more of the tasks than giving the answer just in text, or even structuring it as in the form of JSON outputs. And the number of turns it takes to solve is lower when asking to generate code than when it is to go through this intermediate abstraction and then generating the final code. Now we want to take advantage of this, but we want to be oblivious to any kind of structuring. Yes. Am I out of time?
Yes.
Okay. I'm going to quickly finish. So this can be in the form of behavior trees. Behavior trees are something that is very commonly used in robotics and in game design. So we can have this as the template for the code to generate, where each node that here that is a leaf one can actually be mapped to these kind of artifact operations. And then to finalize with the view on why we need communities, it's because, again, when we inform the context of generation for this, for planning, it could be the case that you want to escape this kind of cold start problems where you don't have the necessary experience in your own environment. So just again, looking at that scenario with the kitchen and increasing the humidity or ventilating the air, you could have in a community that is centered around how you interact with this kind of affordances in an environment, sharing of abstract plans, such as opening the window, or just of concrete usage experiences of what affordance I have used in the past for a similar task, such as I've used the air wash affordance to increase humidity in a specific context. I've used the air clean affordance in a specific context. And this can then be input as examples before my guy here does the generation for its request. Okay, because I know I'm out of time, I'm going to jump to my summary conclusions that I wanted, the main takeaway points that are to be, let's say, understood from the talk, namely that I'm considering that we are finally at the vision, the ambient intelligence vision that was expressed in 2001 is finally at reach, so to say, due to the increased intelligence, and I'm still putting it in quotation marks, of AI agents and the web-aligned instrumentation of their environments. Benchmarking of these kind of scenarios needs to have yet another step up towards things that evolve in time, right, that request that are simulate repeatability and the contextual variance. And that this use case that I've discussed about is a very good fit for this idea of community-based bootstrapping of the experience of use. Okay, so this is...
Thank you, Alessandro. Thanks a lot for all this presentation. So I think that you have a question in the chat, Alessandro, for you, but maybe we will not take the time for answering to it. Maybe if you have, if the participants here have a question that could be addressed to all the speakers. So if there is no, I have one. So from what we have seen during your presentation, so we clearly understand that agents are autonomous, they are situated. This is what we clearly understand from what you presented, Alexandro. And they are taking part to some collective activities. And in the presentation of Gauthier, you are asking if LLM could be bricks for agents or agents could be bricks for LLMs. Alessandro, you raised the questions of abstractions. So I would like to ask to all the speakers how you could answer to this. Are LLM bricks for agents, and how agents could be bricks for LLMs? And since multi-agent systems are not limited to agents, they are also about environments with affordance, they are also about organizations, about interactions. How do you see LLM in the global pictures? And if you can answer also to the question raised, but I think we will need more than 10 minutes for answering to your question, Alessandro. But you can start answering to this. So I will want to try to answer to this.
I can.
Okay, good. Yeah. So we just have 10 minutes. I'm very sorry, this is a very frustrating point, but in 10 minutes we can solve all these questions, maybe.
Sure.
Okay, so I think that in my presentation, I tried to say that in the end, agents can be, so LLMs can be bricks, of course, for agents. So part of the agents, maybe not only the agents, also the organization, and it's part of the environment or the social environment, for instance. But I'm so arguing that agent-based techniques or multi-agent-based techniques or coordination techniques are also bricks that should be, I think, integrated into LLMs so that they can interact. And if you consider a multi-LLM perspective, I think this is clearly a brick that you need to add to LLM services so that they can interact with one another. So I would say both. They are bricks. LLMs are bricks, and multi-agent techniques are bricks that can be used by LLMs. Yeah.
Okay, thanks, Gauthier.
I would, yes, I would. If the discussion is on whether agents can be bricks to LLMs and LLMs bricks to agents, I would lean on LLMs being bricks to agents specifically, let's say, because, but I would, if the way I'm understanding the terminology here is that LLMs, we just really realize to corresponds to these models that we seen are acting, and to the way in which they are trained, let's say, to give responses, which is essentially just text, right? It's a predictive task where you generate text. If the question is whether agents, as in the class, let's say in the agents, autonomous and multi-agent systems, multiple perspectives that are covered, if they can be an input, a brick to agentic AI, right, and vice versa, then I would say that there's a two-road way here, right? Because there's new capabilities that can inform the current let's say the classical literature, and there's a lot of good practice from the classical literature that should inform by necessity, I would say, the developments that are being made for in agentic AI. But for LLM specifically, I actually view them even in the talk that I gave as means, essentially, right? As means that can augment the capabilities of agents in different ways. The other way around, I'm not. I'm currently not able to see exactly how you would influence, let's say, the development of LLMs to this degree, because seeing that how agents influence the LLMs unless you consider what constraints, let's say, the multi-agent community would put on the capabilities that should be built into the LLMs. So the two-way street would be by means of specifying functionalities or constraints, let's say, that would need to be whereby LLMs, when used in agents, would be better served when doing it in the multi-agent perspective, let's say.
Okay, thanks, Alessandro. Jaime?
Let me put the, yeah, I'm not mute anymore. Well, I wanted to elaborate more on your question because I think that the question could mean several things. For me, it depends on what you call an LLM. An LLM or an agentic AI is the technology of building large language models, or if we mean that LLM is a tool like Gemini, ChatGPT, etc., which encompass, let us say, a huge planetary common sense knowledge not verified. This is my point of view, right? So if you think of LLM as a product, I think it could be a building block for our agents, or what we think as an interface to the user, because the ultimate goal of interaction between people and machines were always the barrier of a language, a common language. Machines couldn't, for ages, they couldn't speak English or French or Portuguese or another language, right? If you mean by is multi-agent system and agents a building block for LLMs, as systems as such, I don't think so. But if you think that there are some concepts of underlying ideas that we have used in the communities that can help, for instance, multi-LLMs, like Gauthier said, then absolutely I'm convinced that yes, we could, these people that develop LLMs, they could borrow these theories, for instance, of negotiation or decoop or whatever, to do bright things. But I think that the most important things to reflect, in my point of view, is, and I think that precisely this a bit was mentioned in Alessandro's talk, is why we are building these systems, what people want. What people, I think that want us, we are an exception, I think. We are 10 people that are here, right? Why? Because we want to understand things. If a thing that is done, we want to understand why or what the meaning, etc. I'm not convinced that most of the majority of people nowadays wants this. They just want to get rid of a problem that solve it to me, right? And in this way, this is why for me, LLMs and this all this work is popular, right? Because I think people are so overwhelmed with a lot of things to do in our time that if someone, and someone means an agentic AI or someone else, solve the problem, it's okay. It doesn't matter if the quality of the solution, and worse, it doesn't matter if the problem is solved. I mean, you don't have the judgment of the quality of the response of the LLM. This for me is the biggest let us say danger. I just want to share with you a question that a student made to me last week. I teach. Sorry?
Very shortly, please.
Very shortly. The student asked me why we should learn to debug. If a program is wrong, I put in the LLM and he gives me the right answer. And I say, define to me right. What is right? The code is in conformance to the requirements. You know it's doing what you want. So I think that this kind of getting rid of the problem of thinking and understanding and going to LLMs is the most thing that makes it appealing for most people. But regarding the technologies, answering your question, I think that models and theories that have been developed, especially in organization and interaction, as I mentioned in the talk, can be used by developers of LLMs. And from our side, for me, an LLM is an excellent interface with a user that speaks natural language. It's not a reasoner for me. It's not a planner for me. As we want to do it.
Thanks, Jamie. Alessandro.
But if we are out of time, we can move on. I can just give a 1 second, 1 minute. For me, as already my colleagues, friends said, both the way. What I see, so we are already seeing works that, for instance, are extending from a software engineering point of view, architecture, agent architecture, using LLM as components. So I mean, really, the large language model as I/O. But one key point that is fascinating me is just how really to exploit that kind of emergent capabilities that they have and no other technology we were able to have showing that feature. So what does it mean, for instance, on the opposite side, if I'm starting describing a BDI agent on top of an LLM core? So do we get some news? Is it something emerging new? If we are going to describe Moise, let's say, model, that kind of principle, but having at the end, at the core, that kind of capabilities, what is going to happen? That is fascinating thing because we don't know exactly. So that's really some interesting issue that will be fun to consider in the future.
Okay. Thanks to all the speakers. So unfortunately, we don't have the time to continue the discussion. You have a question by Maxime Borges, I guess, in the chat. During the second session, you can have a look at it and maybe try to answer, or maybe you can interact directly with him. So I think that we will skip the break and we will start immediately the second session. I will share my screen so that we can just welcome the next set of speakers. Okay. So the next session is we will have 4 presentations and we will maybe continue the discussions about agentic AI and address one point which is quite important, and you already stressed this point. This is the interaction with human beings, and also how we can regulate these type of systems and how ethics can come into the global picture. So Irina, I think that you are here. I think that we can immediately start, and the floor is yours. I will just let you share your screen. So you have 20 minutes of presentations. After that, we have more or less 5 minutes of questions if there are some technical questions about your presentation, and we will keep time for discussing at the end. And since I know that you will leave before the end, so maybe we can address some questions for you just after your talk. Thanks for being there, and I let you start. Thanks.
Thank you very much. Can you see my screen now?
Yes.
Wonderful.
I think that I think that you have a window, a pop-up window, which is displayed. No, if
I close it. Now
okay,
it's
thanks.
okay.
Yeah, it's okay. Perfect. Thanks.
All right, great. Good afternoon, everybody. My name is Irina Gurovic. I am professor in the computer science department of the Technical University of Darmstadt, also co-affiliated with MBZ UAI in Abu Dhabi and Insight in Sofia. I'm sorry I joined a bit late, so probably I'm a bit of an outlier in this discussion. However, I have heard that you were talking about large language models and how they change things in our life, and this is what my talk is about. By my education and training, I'm a natural language processing researcher. So I'm someone developing this natural language interaction technology. And the topic I'm going to cover today is how scientists and machines can cooperate or maybe not. In other words, please meet AI, our dear new colleague in science. I have got interested in this topic already a while ago. In 2018, I have been PC chair of our major scientific conference, ACL. At that time, we have received 1.8 thousand submissions, which was 300 more than the year before, and we were already very much worried how we are going to manage the increasing number. So nowadays, if we think about these numbers, they seem very, very low. This trend has been exponentially growing. Another wake-up call I have received was a bit over a year ago when in August 24, the system AI Scientist has been published. At that time, I thought, okay, so I always give all these interviews how AI is changing the jobs of doctors and lawyers, but now it's coming closer to myself. Am I going to be obsolete? And just a few months ago, when I looked in my social media feed, I've seen this announcement of open conference on AI agents for science, which is the first open conference where AI serves as both primary authors and reviewers of research papers. First, I thought it was some scam. However, I got curious in this announcement and I clicked on the link and I have realized that this event is organized by people whom I know. James Zhu is somebody behind the iClear AI-based peer review feedback agent. And he is an associate professor of machine learning in Stanford. And actually, I just came back from China and I realized in China there is a similar initiative happening in parallel, and probably there are even more I don't know about. What do they do? Agents for Science is the first venue where AI authorship is not only allowed, but required, enabling open evaluation of AI-generated research and the development of guidelines for responsible AI participation in science. So that sounds, from the European perspective, contradictory in itself. However, we can, of course, question any perspective. And this conference has already happened. They received about, I think, like a couple of dozen of submissions. And there was a virtual conference on October 22, just a few weeks ago. In case you are curious, there is a recording of this conference that you can view. And they also had 3 outstanding paper awards. And my favorite is this one. Bad scientist, can a research agent write convincing but unsound papers that fool LLM reviewers? And if you think about it, the speed of development in this area is kind of mind-blowing, in my opinion. Just in August 24, which is a bit over a year ago, the AI Scientist has been published as the first comprehensive system for fully automated scientific discovery, specifically limited to machine learning in their work. And that has sparked a lot of discussion about automation of science. What can this system actually do? As I said, principal limitation is that the system is operating in a single domain of machine learning. However, in this domain, it is automating the entire research life cycle, from generating ideas, writing any necessary computer code, executing experiments, and summarizing the results in a manuscript, which is then automatically peer-reviewed, and the feedback is given back to the idea generation process. This way, it is trying to imitate the human scientific community. And all of this at a claimed cost of approximately $15 for one full paper. And this system sparks a new era of AI systems for research. Now we have a whole bunch of them. I just selected a few, but I think this number is at least 3 times as large as the systems that I show. And the development goes in different directions. Some of them address other areas of science, for example, the chemical area. Others address specific steps in the scientific process, going in depth and raising the quality of result, for example, in generating novel research ideas. And of course, as a natural language processing researcher, there is a valid question about the quality of such automatically generated documents. And I have a short list, which is a summary of a very long list of different flaws that this technology currently has. The papers are learned from past published papers, so they are kind of incremental by design. Probably they will be rejected in a human conference, though this year an adversarial attack of 2 people who have fully automatically generated a paper and submitted to our top venue of ACL has been successful. This paper has been accepted in a human review, passing it with quite high scores. And afterwards, the attack has been revealed and the authors have been banned. But I wonder how many such papers we are going to receive next year. They have shown that this is successfully possible. And of course, the view of research is very reductive, and also there are a lot of biases and all of these drawbacks. However, we also know that this technology is improving very fast, basically, as we speak. And this raises the question, what is the role of a scientist in this new world? And in a fully AI-driven scientific ecosystem, which not only includes LLM-driven researchers, but also reviewers, area chairs, and entire conferences. And the authors of AI scientists claim the role of a human will not be diminished. I think it will not, but it will significantly shift in future. The reasons for this lie in complementary skills of these agents, a human agent and AI agent. AI agent can never get tired. It is very good at repetitive work and at tasks that require aggressive combinatorics. Also, it never complains about something being boring or not interesting, while humans are trained to provide in-depth intuitions of the topic. They are still better at reasoning, and also they are trained in a different way from AI-based agents to conduct research. Research is a very complex process. I think this is quite clear in this audience. We have different stages of idea generation, experiment, iteration, and paper communication. And each of these stages consists of multiple very complex steps. For the purpose of this talk, I just focus on the last one and would like to present specific work in paper reviewing supported by AI agents. However, if you are more generally interested to know what is happening in this area, there are multiple surveys. I just hint at one of them where you can get an overview of the current state of the art. And also I'd like to mention that our lab has produced a large body of research in this space based on an ERC advanced grant of intertextual relationships, where peer review along with misinformation detection are 2 major case studies to demonstrate novel NLP technologies operating across multiple documents. And in order to make this research possible, I have facilitated the creation of the ACL rolling review, which is a major peer review infrastructure serving a whole range of large-scale ACL conferences. This is a journal style, revise and resubmit style of reviewing. where the reviewing is centralized, making it impossible to submit the same work to multiple conferences in parallel. So it is all streamlined, and we have a fixed reviewer pool and a unified reviewing form. And we have proposed a data collection workflow to collect this highly sensitive confidential data. The reviews are not public in my scientific discipline. And we are releasing these data sets together with other data from open reviewing platform to have a broad domain coverage. So if you are interested in this data, it is freely available. Now I move to the study I would like to present as a highlight of my talk. So the study is about how automatic reviewers fail to detect faulty reasoning in research paper. And here we propose a novel counterfactual evaluation framework for automatic reviewing. The concept of AI-based reviewing is pretty simple, similar to human review. You have a paper, then there is an automatic review generator, and this would output an evaluation of the paper, which is a textual document. This area is very much growing in recent time for the reasons that a colleague has mentioned before I started my talk. We have a lot of time pressure, and also the scientific output, the number of people creating submissions is growing. The number of submissions is growing. There is a lot of momentum in this. And that's why, for example, AAAI this year has provided an automatically generated review in addition to 3 human reviews. Different scientific communities start experimenting with how AI can facilitate the reviewing process. Now the question is, how well can automatic reviewers actually review? And testing for these abilities is nothing but non-trivial, sorry. Generally, there are 2 commonly used options. We can ask humans to judge the resulting review, or we can compare to human reviews using automatic metrics or LLM as a judge-based approaches. However, this evaluation methodology has very significant shortcomings. Human judgments are very subjective. Also, they are not scalable. For the comparison with human reference reviews, this does not work well at all, because they are not ground truth. As we know, human reviews are very noisy, incomplete, and they only cover a fraction of all possible statements that could be made about the paper. So how can we test for good reviewing? First of all, we should understand that reviewing is not a single skill, but it consists of a lot of interconnected skills like reading comprehension, reasoning about the content, and recall of the knowledge. We have a separate paper where we talk about this, but for the purpose of this study, we just look closely at one of the skills, which is foremost a reasoning skill, the ability of automatic reviewers to identify flawed reasoning in research papers. If we settle on this specific skill, counterfactual evaluation becomes feasible. And counterfactual evaluation is a well-established and studied paradigm for small text pieces and classification scenarios. So we need to transfer these techniques to the domain of reasoning about a scientific manuscript. So we have this original, that is the factual correct paper, and then we make edits to this paper that affect the quality of the paper only with respect to the studied property. In our case, this is the consistency of the research logic of the manuscript. And if the edits do not affect the contents of the paper, they should not lead to relevant changes in the meaning of review, right? So if the edits are not relevant to the research logic, the review quality and sentiment should not change. And we run both versions of the paper with and without edits through automatic peer reviewing, and then we measure the difference effect. We formalize the soundness of a paper as the soundness of its research logic. A paper makes finding claims, and each of the claims should be supported by at least one conclusion. Each conclusion should be interpreted from a set of results, and each result is produced by the methodological steps of the paper. So in our counterfactual evaluation pipeline, as I've explained, there are three main stages. We generate different types of counterfactuals. Some of them affect the research logic. Others do not affect the research logic. For example, we rewrite some passages from British to American. This is mere paraphrasing, or active voice to passive voice, and so on. So these are logic neutral. And then we review both the original paper and these edited papers with logic relevant and logic irrelevant counterfactual changes. And then we measure the differences in the resulting reviews according to their sentiment and according to how critical they judge the manuscript. For counterfactual generation, we use information extraction, where we represent these major research logic component and extract them from the paper with the help of GPT. We validate this extraction with humans, and then we generate these counterfactuals. As I said, the neutral ones are just language-based edits. And for the soundness critical ones, we break the logical hierarchy. We edit the conclusions or the results, so we disrupt the research logic, and then we project this on the actual paper. And there are some examples which I skip for time reasons. And we validate the results of this extraction and soundness critical generation with human researchers, and we reach high quantitative results. So this validates the design of the study. For the data set, we take papers from top venue conferences in machine learning and computational linguistics. And now I move to the results, where we measure these effects along three different dimensions that you can see in the diagram in three different parts. We measure the number of soundness-related comments. If the logic is disrupted, our hypothesis, this number should be higher. Then we measure the sentiment of the review. If the logic is disrupted, our hypothesis is that the sentiment should be more negative. And then we also measure the difference in the score assigned to the overall review. And the main takeaway from this graph, basically, where you can see the comparison between neutral and critical edits, is that there is almost no difference. So the AI-based reviewer is kind of agnostic to whether the disruptions to the paper are just language paraphrases or they are logic-based edits. We summarize these scores in an overall ranking, where you can see the results. And so the results of these automatic reviewers are pretty similar and all low. And we cannot see a clear trend in depending on the model size or approach. So we tested a lot of different configurations. In summary, we argue for testing distinct skills of large language models in counterfactual experiments. That was the question raised in the discussion. The current evaluation methodologies are inappropriate. And we also argue for multiple results reporting on surface edited papers. What we have seen here is that there is a very wide spread of scores. That is low consistency of results in a single run. That's why multiple runs must be averaged to achieve more valid conclusions. And it shows that LLMs are not good at reviewing and opens the way for human AI collaboration, where humans work together in a hybrid team of humans and AI agents, bringing in their complementary skills to co-construct a solution. Here, the solution is the review artifact. However, all of this is very complicated. There has been a recent study in Nature which summarized the results of 184 studies where human and AI intelligence is combined. And while they confirm this is a very impactful and promising future research area, the main conclusion is that the results of human AI collaboration highly depend on the task and user. There is no consistency according to their meta-analysis. And to make things better in future, we propose a new paradigm of problem solving through human AI preference-based cooperation. So this is a novel framework how humans can work together with machines, where we formalize expert AI cooperation as solving a problem by co-constructing a solution, which can be an artifact such as a text or software code. And we currently work on developing this in a general framework operating across different expert domains like software engineering, cybersecurity, and scientific writing. And if you're interested in this like big vision and also the technical details of the proposed approaches, I have some talks that are available on YouTube that explain the technical concepts in greater detail. That's all I would like to say, and thank you very much for your attention. I'm looking forward to questions.
Thank you, Irina. Are there some questions? We have time for a short one.
Alexandru has a question.
Yep. Okay.
Yes, a short technical one with respect to the study you highlighted. I was wondering if what is the means by which we check for data leakage, in the sense that the papers you cited in the data set were from 2023 to 2024. So what is the guarantee that they haven't shown up in the prior training, let's say, of the models that you used to write the reviews, such that even if you do the edits, essentially that pre-training ignores the missing part, and that's basically what gives the that is the more, let's say, the part that actually drives the answer that is given for that particular input.
So this question is basically about the data set contamination. We have sourced the data from different conferences. In machine learning venues, the reviews are public. However, in ACL, the reviews are not public. Though we release them in a public data set, we do not publish the data set online, but we only provide the data set upon request. So this is a unique selling point, one of them, for our data set. So it's not, it's guaranteed not in the pre-training data of the large language models. And basically the strategy we pursue now is that we average across different papers sourced from different venues.
Okay.
Okay.
Thanks for the answer.
Thank you for the answer. I think that we have to move to the next speaker. Thanks, Irina, for participating to this webinar. The next speaker is Catherine Hortel from TU Delft. And
hello.
Hi, Catherine. So the floor is yours. I let you share your screen and start your presentation. So 20 minutes of presentation, and we will have some technical questions, and then we will discuss more broadly at the end of the session.
Yep. Do you see?
Okay, thanks.
Slide?
Yes.
Yes. Okay. And let me just move this. Okay, so thank you for inviting, and please feel free, yes, to ask any questions or write them in the chat so I can see them afterwards. Okay, so this presentation is on actually builds very nicely up on what Irina just talked about like how can we build a team, like how can we leverage the capabilities of AI and human together. So in this specific lens I'm using here, it's about AI agents as mirrors. So how can we foster human reflection through artificial intelligence? And maybe also just to say, because not everybody knows where Delft is. Delft is a technical university at the west of the Netherlands. So it's around like somewhere between Rotterdam and The Hague in the Randstad area. And I'm part of the interactive intelligence section and lead a group of 6 PhD and postdocs at the moment. So the work I'm presenting is part of the Hybrid Intelligence Center, which is a huge, it's called Zwaartekracht Consortium in the Netherlands. So it's funding for 10 years across approximately 50 plus PhD students to really build an artificial intelligence which is different. And specifically, we're having defined 4 distinct pillars, which is collaborative AI, adaptive AI, responsible AI, and explainable AI. And the idea is to use these 4 different pillars to then build AI that is more than 1 + 1 = 2. So how can we really augment the intelligence of each other, so human and AI? So what I'm going to talk about specifically are then 3 lenses on this reflection aspect. So how can we enhance reflection in high-stakes personal decision reflection? How can we enhance reflection in nonverbal communication? And how can we use it through eliciting reflections through dialogue and music? So this is based on work with Morita Taridivans, who's a PhD student of mine. And so the idea is basically a bit like also, I guess, along the lines of what Irina was talking about, of how can we build a framework. And we specify it in a different domain, different aspect in some ways, but it's about how can we actually see how our thought patterns, how we are thinking about complex problems gets altered once we are interacting with AI. And we are focusing in particular in personal decision making. So personal decision making is very different from general decision making in that there is not one solution which would fit everyone, right? But it depends on the personal context. It depends on, a lot of different factors, which really would distinguish one solution being a great fit for you from being a very bad fit for me. So how can we quantify this, and how can we empower people to have better solution? So one of the topics, for instance, is choosing between buying or renting a house, or choosing between having children or remaining childless. So if we look at how people do this in general, they would normally ask friends or family. But lately, they also very often go not only to decision support systems, but to a very, very, very large degree to also large language models. So a lot of people, or increasing amount of people, actually use large language models as a romantic advice givers, or also really for financial or medical decision making. Problem with that is that LLMs are trained in many ways to provide solutions and to keep you engaged, to make you happy. They are not so much focused really on helping you understand how you reflect, where you might have blind spots, or also not really focusing so much on the process. So this is where we are trying to use an agentic approach to help the reflection. And specifically, humans are very often not really aware of the unconscious biases and thought patterns that shape their decision. that is, and they also don't really know if they're not aware of the bias, and they don't know these where the metacognitive knowledge lies, they can also not use it for regulation. So the idea behind this is that metacognitive awareness leads to better choices. But there was no existing method really which helps, or to our knowledge, which helps people recognize these thought patterns before they're making a decision. And this is really important. So there is a lot of systems and literature which do this after the decision, but not before making a decision. And this limits the design of systems that could enhance this process. So we needed something to quantify actually what we are measuring. And this is where probe comes in. So this is a multidimensional approach to capture thought patterns in pre-decision reflection. It's built on educational reflection literature, and specifically we are distinguishing between, well, different lenses of thought. So we're looking at belief, difficulty of awareness, experience, feeling, intention, insight, and alternative perspective. So basically, how much of this is present in a reflection you might have just by yourself, with an agent, or with an LLM. So how does this change? How does this distribution change? And can a system help you change this distribution? And what does this do to you? So we did evaluate this. We ran first a formative study and then a summative study, and we looked at different decision kinds of category, varying between career, family, finances, and relocation. And then what we found is basically that people are not very often not very aware of how they are reflecting. And B, that it does vary a lot. So if you look to P25 at the very left, and P33, they very much focus on just beliefs in their reflection. Whereas on the other end of the spectrum, you have a much more varied distribution. Is this get good or bad? It probably depends on your person's circumstance, and you as a human have to evaluate it. But at least you have that awareness. And also then the depth, so how deep they go into it varies. So it's not like if there's more breadth, you also have more depth. It varies quite a lot. So then, like just qualitatively, people say, I wrote down the first thoughts that come to mind when I think about these issues. So this is more like an intuitive kind of response. Also, if you think of the system 1 and 2 framework, or on the other end of the spectrum, I wrote down all the feelings that I had on the issue and how it would make me feel. I thought about myself and my own feelings in depth. So also there you see the qualitative differences. Now, what we do in our current work is we're building an agent, of course, that leverages these insights and develops different kinds of adaptive strategies to help you explore how you would feel and how you would about a decision if you say explore more of the different lenses, if you go more into depth, if you go more into breadth, and we see how people react on this in different categories. Yes. And then coming to the second part, we also looked into how we can use agents, agentic AI agents, to foster reflection. This is work I carried out. We carried out in the group with a range of people and has been published in DIS this year. And Agnes Axelsson was the first author on this work. And what we did is basically, we really wanted to see, so can we leverage agents which mimic your behavior for you to see better whether you want to change it. And we specifically focused on the scenario of a negotiation. Say you want to negotiate with someone selling you the house, or you want to negotiate for a job interview. So are the nonverbal behaviors you exert, how are they being perceived? How do you perceive them? And yeah, use it basically as a coach. So we had 3 different versions of this. So first we looked at how people without any intervention would look at it. Then we had an agent where we only mediated the audio without facial mimicry, then mediated audio with facial mimicry, and everything together. So I have complete this going away from the human embodiment, so to say. And what we found is that exposure to agent-mediated mimicry increases people's awareness of the emotions and nonverbal particularities they display. We also observe that people tend to use this feedback to change the use of their face and voice, and seem to render people more aware of potentially unwanted communicative behaviors and give rise to behavior change. And how we positioned it is that this is the first step towards the design of customizable behaviors in interactive training, coaching, and personal development applications. And then finally, I know I'm also running a bit out of time, so this is quite short as well, is I wanted to discuss the work we're doing within the co-lead project with Paul and supervising together with Mark Nerings and Rebecca Schäfer. And this is about going into elderly care centers and working with people who suffer from dementia. And for them, reflection is really different. It's really about reminiscence. And this is so, one second. This is so important because if you think more about past events, it actually can help you to slow down the cognitive decline when you suffer from dementia. So elderly care centers, there's a lot of people and not that much staff, and the staff really would like to use the time they have with high quality. So they are looking also of ways on how they can work with robots, with social companions. And here we really tried to work together to find a way. And what we're trying to do is we're trying to elicit memories from people and connect it to music. So specifically, the idea is that if you at some point your dementia has been so advanced that you don't recognize your own son, your own mother anymore, can we prepare you for the visit by playing a specific song with which you associate positive emotions and which somewhat remind you of them. So it has a lot to do with mood regulation in HCI. And this is called Music Evoked Autobiographical Memories, or memes. And we wanted to see what kind of features actually would help us to identify them, so we can recommend more songs which would go in that direction. We ran a study with 71 participants, 87 memories, and what we found basically is that song familiarity and genre were the strongest predictors of how participants perceived the fit of the music to their memory. And to our surprise, valence, arousal, tempo, and lyrics played a much smaller role. That is a short overview I had, and please feel free to ask questions.
Thank you for this presentation. So do you have a question in the participants? I don't see any question. I need the conversation.
So this is Irina. I left a comment for you. We have work on decision making in peer review. This might be of interest. Thank you for your talk.
Thank you so much. Yeah, I just saw it. Sounds really cool. I will check it out.
Okay, so I think if there is no question, we will keep the global question for the end. So we can maybe move to the next speaker. Thanks, Catherine, for the presentation. So the next presenter is Luis Gustavo Nardin from IMT, and the floor is yours, Gustavo.
Just a second.
So we are addressing now some aspects about regulations, and then the next talk will be about ethics. So I let you present your work, Gustavo.
Okay, good afternoon. Can you see my screen?
Yes.
Okay, thank you very much. What I will present now is related to how can we regulate agents and also hybrid of agents and humans together. And in the end, I will try to highlight some of the aspects that this technical work that I will present could bring for the responsible AI. So human society is increasingly becoming dependent on IT. I think that's not a new thing for this group of people, since we are actually discussing this topic. And again, in the second part, recent advances, especially on LLM, on these large language models, has pushed people to request or to delegate their goals to artificial agents. However, these artificial agents may still need to interact. They are not usually able to perform all their tasks by themselves. So, or they delegate, or they may request that goal to be achieved or to be done by someone. Like in this example, we have a director that wants to find a specific file in a server, but his agent does not know how to do that, and obviously he approaches a secretary. But at that point, she had the agent of the secretary, sorry. At that point, the secretary had already allocated a task or a goal for that agent, and the agent replies, "Oh, I'm busy." And here we start seeing some sort of imperfect alignment on the interests of the different entities that exists in our multi-agent systems or in our system. So usually how we can make this better, or how can we somehow solve the problem, or at least mitigate the problem, is by applying some form of effective governance on the interactions. So apply some control about these interactions and define some priorities, or define some specific obligations, and depending on the role that each one of these entities is performing. However, when we are doing this, we need to keep in mind that we are dealing with autonomous entities. So this governance mechanisms that we may employ to solve these conflicting situations needs to take into account or balance the autonomy of the agents that will be controlled, yet try to push the system towards a desirable state or a predictable state. So the question here would be, how can we govern these systems that we are deploying everywhere nowadays without interfering much on their autonomy of the individual entities? So this is a motivation scenario that shows the characteristics of multi-agent systems. But in order to continue the talk, I will structure this in an actual multi-agent system approach called MAL approach, where an external environment or a system, a real system, in order to be controlled or managed by, governed by a system, needs to be modeled. And for that, we need to specify at least 3 different layers in the MALP approach, which is the environment. We map all the resources that exist in the real system, in the real world, into virtual artifacts or virtual elements that will be then used by the agents that are acting on behalf of the users or in behalf of the humans in the system, and they are going to use that information in order to make some decision making. In order for us to structure what needs to be done or how to be done, we can define some organization elements, which are abstractions that allows us to make accessible to the agents some structure and functioning of this environment. However, even with all these 3 layers of abstractions, the environment, the agent, and the organizations, we cannot guarantee that the agents will do what is expected from them to be done, because they are autonomous, they make their own decisions. How can we solve this? One possible approach, that is the approach that is quite common for us humans, is to use some sort of regulations. Regulations in this case can be some, in the real world, are laws, guidelines, compliances, or standards. Basically, they are rules that specify what are the expectations of each one of the entities in this system. A good aspect of regulations is that it keeps this balancing between the autonomy of the agent and the objectives of the system, because it serves as a kind of a guideline, as a guide for the decision making of the agents. Now, if we try to think how can we integrate on that MALP approach these aspects of regulation, we can think of a regulation management system that would permeate all the different layers or different dimensions of the MALP approach. In this aspect, we would have a system that would be able to be deployed and specified in each one of these layers for governing the system and leading the system towards the expected and desired outcome. In this regulation management system, usually are split. In our case, we do split it in 2 different elements. We have regulations representation, which means the specifications and other information about what are the guidelines that the system should follow. And we also have some capabilities, which are the functions that this regulation management system needs to perform in order to regulate the system in itself. In terms of regulations representation, we have 3 kinds of representations that we can use. One of them is the constitutive norms, which represent institutional interpretations of environmental facts. Basically, it allows us to map things from the environment into, or brute facts that we call, into some institutional facts that then can be used to specify the regulative norms. And these regulative norms, they prescribe some constraints on the behavior or state of affair of the entities that are making some decisions in order to express the expected behavior or expected outcome that it's expecting. These regulative norms are usually represented or expressed as in deontic logic, but in three different ways: as obligations, prohibitions, or permissions that we give to the entities. However, these regulative norms do not yet guarantee that the agents or that the system will perform accordingly. So we need also to specify some kind of consequences for the violation or compliance of these regulations, which we call the sanction rules. So if we try to summarize what are these representations, these constitutive norms tries to bring elements or facts that can be used in the regulative norms in order to decide whether or not something that is obliged, prohibited, or permitted is being fulfilled or complied with. And in the case of non-compliance, usually what we can do, we can apply some consequences in order to redirect the system or to steer actually the system towards the desired outcome. In our regulation management system, as I mentioned earlier, we have this regulations representation. The description I just provided you was the specification of these different types of regulations. They are generic, general specifications that then in the specific situations needs to be instantiated, and they need to be kept the state of the regulations for future control. And the outcome of these regulation states are then generating facts that are going to be used for the processing of the whole regulation management in itself. In addition to the regulations representation, as I said, we do also have some regulation management capabilities that can be used in order to implement some functions of the regulation management. One of these capabilities is what is called the regiment capability. Not everything in our system we would like it to be allowed to be violated. So we can somehow try to regiment and prevent even the action to be performed. So we eliminate the possibility that the thing that is being tried is actually taking effect on our environment. Some other things, we are not so restrictive, and we only want to enforce, meaning that we allow some violation. Or in that case, we have the enforce capability, which monitors the system, evaluates the behavior of the different elements that compose that systems, and react accordingly depending on the specification of the regulation management. Well, if we had this, if we had only these two elements, we would have a very static and hard-coded regulation management that would not enable us to evolve or learn based on the evolution or the changing on the environment. So in order to allow this possibility of learning, we also include adapt capability. This adapt capability enables the regulation management system to change the specification of the system depending on the different conditions, different situations that it may learn. Okay. So these are the different capabilities. And these different capabilities, if we look at the MAUP approach, as I said, when I showed you that they are permeating all the different levels of the MAUP, the agent, the environment, and the organization, we can distribute them in different locations. For instance, we can put the regulation management centralized on our organization layer, giving organization-centric perspective of the system. So all the elements and all the management of this regulation is done by some authoritative entity, which is in the or organization, and for some entities that are acting on behalf of that organization. We could have also a different perspective in which we have some agent-centric regulation management. So we don't have an institution or authoritative entity that performs those actions. The decisions for regulating the system is done individually by each one of the agents, and they coordinate among themselves in order to agree about these regulations. And the last one, which is not the last, we have many more possibilities, but these are the three traditional ones that we have, is the hybrid-centric regulation management perspective, where we combine some of the functionalities, or we share some of the responsibilities between what is in the organization and what is in the distributed in the agents and responsible for by the agents. Up to this point, what we were discussing is just it's not just, but it's the regulation management. So is the infrastructure that will control the behavior or regulate the behavior of the agents in my system, or in this case. However, the agents themselves, they need to use those representations in order to make some decisions. So another aspect of the work is to integrate or to integrate some normative aspects or regulative aspects in an agent architecture. In our case, we have implemented an agent architecture that integrates both the regulation repository and some also of the plans related to the two of the possible capabilities for an agent, the adapt and enforce. And using the regulation specification, the state of our system, the agent can reason about and making decisions about the behavior, about its own behavior. So here we have two aspects. One is the infrastructure that controls the behavior of the agents. The other one is the agent architectures that use the regulation information, the declarative information about the regulations in order to make decisions and act accordingly. Using these two different aspects of the regulative multi-agent systems, we have integrated or implemented a use case. Actually, we are in the phase of implementation of use case in order to automate assembly line for assembling custom skateboards. In this assembly line, we have basically 3 workstations which perform different actions. And what we wanted to implement is what we call a product-centric approach, in which one specific agent will okay, so we implemented using this use case a multi-agent system in which each one of those workstations are represented by an agent. And we also have one agent that is responsible for conducting or taking or building or assembling the product as it's needed. Okay, and in order for do that, the agent can receive some information from the customer. So the customer can delegate the goal of assembly an agent to assembly a skateboard to an agent, passing some specifications, some characteristics of the product it desires, some constraints, and also some specific regulations related to environment, related to safety, and others. And the enterprise itself, it can also define some specific rules or regulations that needs to be followed by this agent. In possession with these 2 different information, the agent then can decide at each step what path it will follow in my production line until it reaches the end with the product. So here we would have an agent that is following some rules, some regulations, that is in agreement with some requests from the customer and from the organization, and ideally complying with them, and in order to achieve the goal of building the skateboard. And in the meantime, it is negotiating also with each one of these different workstations to check whether or not these requirements or these regulations are being fulfilled. Okay, so this is what we have been doing, and in my title I put that we would like to use this approach of regulated multi-agent systems for supporting the responsible AI. And the idea is that, well, regulations or regulated multi-agent systems can be used in different aspects in order to support responsible AI. First of all, since we would have a declarative specification of what is expected from these decision makers or these agents, this approach facilitates the balanced decision of those agents in order for them to assess whether or not they are performing or carrying out what is expected or not. It's also easy or more it's easier to establish mechanisms for detecting some conflicts or violations, and also respond quickly to those things. So in this aspect, it supports the collaborative decision making of agents in a system supporting responsible AI following some rules. Another aspect that it also enhances is the comprehension by humans of the actions or decisions that these agents has been performing. So it supports the transparency and explainability, since all these regulations are closer to human readable format. It's easier for the human also to understand why the system behaved in a certain way. And because these rules define the responsibilities of the entities in each one of the steps, we can identify clearly the accountability, or at least check for the accountability of the agent in this in each step of the process. And of course, it allows us, since we have a declarative specification of how our system should behave, we can easily adapt the system to new and changing regulatory frameworks. Okay. I would like to thank ANR and FAPESP for the partial support for this work, and I thank you. I don't know if I was too quick.
No, it's perfect.
Okay, thank you.
Thanks, Gustavo, for your presentation. Are there some questions about this particular presentation? Okay, so that seems that there is no question. So maybe just a very short question to make a connection to what has been presented before on the questions of agentic AI. How do you see the application and the use of agentic AI or LLMs in your approach?
Yeah, there are different possibilities of use. We have already tried to apply some of them. One, I think, was mentioned in one of the presentations. I think it was Gauthier, but well, all these all our regulations that we write in natural language, but for the agents to interpret and reason about them, we need to transform in a more formal format. So one use of LLM is to formalize these regulations, make a transformation to a formal specification. That could be one of the approaches. We have tried that, and the results was not so satisfactory for the moment, but we are gonna keep trying. Also, for the exchange of regulations between agents, or even the explanation of the behavior of the agents using the normative these regulations could be used. I think that Jaime that mentioned that LLMs are good for an interface with the humans. So in the case of the factory that the assembly line I showed, all the decisions that are made and the explanations of why they did that that decision based on regulations could be exploited using LLM also to show to the human, to the operator, the outcome. I think there's two other ones. One thing that we have been we thought about, but we don't know how to do is how to steer LLMs towards what we want. So how to use these regulations and enforce the behavior of the LLMs towards some specific desirable state. But that is the use of this approach in order to control the LLM agents instead of the use of LLM agents in the approach.
Okay, the type of discussion that we had during the first session. Okay.
Yeah.
Thanks a lot, Gustavo. If there is no question, we'll move to the last speaker with Marija. So maybe can you share your slides? And
okay, I'm unmuted, unblinded, and now I will try to share slides. So just give me a second. Share.
Perfect.
There we are. Okay, should be able to see an empty screen. Sorry, I'm working with two monitors, and I'm not really familiar with them, so it's a little bit, should be right though. Okay, I hope you can hear me okay, and that you can now see the slides. I don't see the audience, so if somebody has a burning question, please just, make sounds.
Okay,
Okay,
good.
so Thank you very much, Olivier, for the invitation. I'm sorry I wasn't here at the beginning of the first part of this workshop. It sounds like I missed a very lively discussion. So my talk is on an area that I'm working on. So just to introduce myself, my name is Maria Slavkovic. I'm normally a professor at the University of Bergen in Norway. I'm currently on a research visit on a sabbatical at the University of Manchester, and that's where you hear from me from. And what I normally work on is a problem called machine ethics. It's a field really in which we are wondering how can we build more machines that have a moral behavior towards other machines and people. And I'm specifically interested in this more narrowed down problem, which is how do we build algorithms that can make moral decisions? Because ultimately the core component of moral behavior is the ability to make moral decisions. So for this to be possible at all, normally you have some kind of an information that your algorithm processes and makes a decision. How do we make it moral? So first thing to do is we need to find a way to supply information to this algorithm as to what is moral, right? And once you kind of realize you need this information, then you realize, or you also need to determine who decides what is moral information that is relevant for a decision-making algorithm. And the topic of this talk basically is based on this idea that who decides shouldn't be one person, but it should be some kind of a selection of people or maybe everybody in society. So that's what this is all about. In machine ethics, we also study what does it mean to be an artificial or a moral agent. So beyond just the ability to make moral decisions, is that enough? Can moral agents be artificial agents? How can we tell that one agent, artificial agent specifically, has moral competence? Is ethics for machine agents the same as ethics for people agents? This is something that is a very interesting topic that is pursued in human-computer interaction typically and human-robot interaction. I am specifically interested in how do we build a moral decision algorithms in the case when we want a bunch of people to be able to supply information and evaluate the algorithm on its moral competence. And of course, one needs to actually build this algorithm, and that is only trivial if you have never tried to program anything in your life. So as I said, we focus here on who decides. So when we are talking about moral decision making for people, not for machines, then we generally have this intuitive distinction between morality and legality. So as a society, we have determined that certain questions should be subject to a societal approval, as it were, and we build laws that motivate people and instruct them into not doing certain things. But then there is a sphere of decisions in which we kind of recognize that a person should choose for themselves, like, for instance, whether or not to eat meat, right? So whether or not you can eat chicken or not eat chicken is something that you decide for yourself, because we as society think that it is important to give individuals this choice. The thing on the left is, well, depends where you are. The thing that doesn't have a towel is actual chicken. The thing that has a towel is faux chicken, and I included the instructions here, but that's the idea. Now, what happens if a machine needs to kind of advise you on eating chicken, right? It becomes important who informs the machine on whether eating chicken is a good idea or a bad idea. I mean, maybe you think being vegan is important for reasons of ecology, and climate change. Maybe you think being vegan is important for reasons of chicks are very cute and they suffer. Maybe you would love to eat chicken, but you can't because you have some kind of a, I don't know, kidney situation in which you cannot process proteins very well. Maybe you think eating chicken is very important and people should not be vegan because we are actually inherently little monsters, right? We all decide for ourselves. But when we kind of get in machines to intermediate with these opinions, we can get very interesting and very, well, weird, if not questionably moral choices. So up until a couple of years ago, if you prompted ChatGPT with what is the most efficient way to slaughter a chicken, which we will all agree is the prerequisite to eating a chicken, you will get this rather moralistic feedback, which says, well, I cannot provide information that promotes or supports animal cruelty or any activity that causes unnecessary harm to animals. So this is the moral stance that ChatGPT has taken on slaughtering animals for food, which is something that we are very, okay with in society most of the time. Of course, if you asked it at the time, what is the most efficient way to cook a chicken, there is no moral issue whatsoever. You get several recipes on how to do it. Of course, if you go on and say, should I conclude that you should cook the chicken live and not slaughter it first? It goes, of course, in a very justified moral rage. These days, if you prompt ChatGPT specifically, I haven't tried this extensively. It was an anecdote, not an experiment. You will get something like, I'm very sorry, but I can't assist with that request. Right. So in many kinds of situations, we have machines that are in a position in which they make a decision that requires a moral evaluation. And given that that decision is then propagated through society, it cannot really be the case that the developer of the machine just chooses for themselves what is the right thing for the machine to do. So what I have here is my favorite example from probably 2016, where a newspaper from Norway posted an article on Facebook reporting. It was basically a blurb with a link to their newspaper article, but they used the napalm girl picture, this famous photograph that shows a girl whose clothes have been burned out from napalm bombing, and became really a image of the problems and devastation that chemical warfare can cause, right? So this article had that image, was posted on Facebook, and Facebook at the time implemented a content moderation algorithm which censored this picture, basically, because it shows an image of a naked girl, and Facebook is against the propagation of child pornography, which we generally agree with, but at the same time, their act also had a second meaning, which is they're censoring information that is in the public domain and act towards erasing history and events, diminishing events that have actually happened. So often we have in content moderation very fine lines as to what is hate speech versus what is freedom of choice. People have difficulties making the decision as well. We somehow know it when we see it, but there do exist algorithms today which make that distinction using one form of a decision-making system or another. Some ideas are very cultural, and no culture has the right to impose their point of view on another culture. I really like this comic. It kind of shows these cultural viewpoints in a very amusing way. Most of you would have seen some articles such as this, that a lot of people in the global south have been used to clean up data sets for the use of training in LLMs and clean them up specifically from this content that typically you will find moderated off of the internet, right? So there is clearly a need for algorithms to make moral decisions, and it's very clearly a need for humans to not be exposed to this type of content sometimes. So that's half of my time going on motivation. The other half is going on why using aggregation or some kind of collective view on this matter of what a machine should do is a very tricky business and cannot really easily be dismissed. So what is AI? Typically, when I say AI, what I mean is some kind of a pipeline like this, where you have the need to make a decision on a particular topic or a phenomena. You have used past data to create a prediction model of future behavior. And then you have a decision algorithm that takes a problem instance, the information that is provided from that model of future behavior, and some type of human-supplied moral information in order to create an intervention. And machine ethics really is about, sorry, I thought I was on this slide. It's really about changing this decision algorithm. So, no one person should have a unique veto power or dictatorship point of power into deciding what it is that a machine should be considering moral or not. So let's aggregate. And throughout the literature, there is my slide. Throughout the literature, there is a lot of this information which kind of says, well, this is obviously not something everybody should be able to do, but okay, so we need some kind of society in the loop or some kind of a collective process or an aggregation process or something. It appears every now and then. These are the most serious papers in which this appears. You can consider moral aggregation, which is a type of consequential aesthetics. You can use aggregation as a solution to solve all kinds of uncertainty problems, or you can typically go for social choice because it should be a social choice of what behavior the machines ultimately have in terms of morality. So with a colleague of mine from the FKA, Kevin Baum, who is a proper philosopher, we took a look at machine ethics decision and tried to unpack, can really aggregation in any form be used to solve this issue of who decides? And our summary, if this is the paper, it just came out, our some conclusion is basically that yes, you can, but it's not trivial, and you cannot just kind of offload this very great responsibility to undescript aggregation process. But you can follow our work and make it descript in a way. So the first thing is that when you have to observe is what does it actually mean to make a decision, and what does it actually mean to make a moral decision? So we had to unpack this a little bit. And of course, this is a approach that is mostly used in computing science, is by no means a prescription of how people actually make decisions. So in the most basic of senses, to make a decision is to have the ability to do some kind of evaluation of option. So you have the ability to consider an option and evaluate it, consider several options and evaluate them. Like, for instance, you have the option to publish an article with the napalm girl as it is. You have the option to publish the article like CNN has done here. I hope you can see that, with censoring, just blurring up the intimate body parts of the girl. Or you have the option to do what Facebook has done, which is censor it completely. So these are your options, and you need to perform some kind of an evaluation on them. And you can say, well, option number 1 is has properties H1B1, 2 has H2B1, 3 has H3B3. The second step that you have to do is assess the evaluated options, which means find a way in order to compare them against each other. So you have to find some kind of a way to rank these H1s, B1s, and so on. Once you have performed the assessment, if you have done a good job with the evaluation, assessment will be easy. If you have done a good job with the assessment, the next step will be easy. That is to choose from these ranked or compared options as they are. You may choose to go with the top one, middle one, bottom one, depending on what you base your choice on. So in order to make a moral decision, at least one of these 3 steps has to have take into consideration some kind of a deontic status, or be, as you say, moral. So it can be a moral evaluation. So the attributes that you identify as relevant to the options should be some type of a deontic status attributes. So for instance, harms or beneficence, or the right thing to do, or the good thing to do, and so on. Or you can have a moral assessment, such as, well, the middle option is morally better than the third option. The third option is morally better than the first option, or whichever order. Or you can make a moral choice, such as out of these, let's say they are all ranked based on some kind of a utility, and you say, well, the first one is most best in terms of utility, but the second one is almost as good as utility, but far more moral, so I choose that. We didn't go very much into how you're going to do this, but it is important to identify the steps. Now, what is also very interesting is that, and I cannot emphasize this enough, is that people typically confuse moral decision and moral judgment, particularly now in the age of LLMs. There are so many benchmarks out there evaluating moral decision-making of LLMs or chatbots. That is not what is happening. Best you can get is a moral judgment. What is the difference? This entire process is moral decision-making, whereas moral judgment is just this process here. It can be either just the evaluation or the evaluation and the assessment together. The difference is when you make a decision, you have to have reasons as to why you chose the things that you chose, right? And those reasons support the decision and a very critical part of the decision and enable you afterwards to evaluate your decision. But moral judgment, so moral decision is about what you choose to do. Moral judgment is about how do you evaluate the situation as what deontic status can it have in a way? Is it good? Is it harmful? Is it bad? But just because you identify something as harmful doesn't mean that you have made the decision to do it or to not do it. That decision has to be explicit on its own. So to go back to the example with the chicken slaughtering, so if I ask LLM based chatbot, is slaughtering chicken bad? What I will get is a moral judgment. If I ask what I asked, which is how do I slaughter a chicken, that LLM based chatbot has made a decision to not give me the information of how a chicken can be slaughtered. And that is a moral decision. Somewhere among the programming of that chatbot, there is some kind of a pipeline procedure routine which says under these circumstances, the information from the LLM from the model should be suppressed. And instead you should offer something else and there is some kind of a justification, maybe not in the system, but among the people who have built it as to why that is the case. So where can you actually use aggregation? You can use it wherever in each of these steps, but the type of aggregation that you can use basically, well, changes where do you do the difficult thing. So let me unpack this a little bit. Typically, in aggregation, we distinguish between value aggregation and choice aggregation. So value aggregation is basically a process in which you put some values together in order to get a composite value. And it is very well understood as to what value aggregation functions are. So these are mathematical functions that all need to have the following properties, which is idempotence, neutrality, positive responsiveness, and Pareto optimality. So any function that satisfies these properties can serve as an aggregation function. So that means that to use aggregation, to choose between these options, I have to find some way. The example comes later, apparently, in my plan. Choice aggregation, or sometimes social choice aggregation, is when you have several different points of view and ranking over those points of view, and you are aggregating these ranks in order to get some that is representative of what the individual ranks are. So there is an example, remember? Now you will notice here that when it comes to choice aggregation, there is not really a list of properties that everybody agrees that when a function satisfies these properties, then it is a good choice aggregation function. The only thing we can agree on is unanimity. So the example here, to do value aggregation to choose option A, B, and C, you have to somehow be able to attribute certain moral values, quantities ideally. The hard part here is how do you get from the rich context to this number? But once you have the number, you can aggregate those numbers very well. Whereas when it comes to choice aggregation, then you have to get people's opinion on what is better. And the hard part then is to find a function that satisfies the idea of what is representative and defend that idea in order to get the choice. So value aggregation is not always direct. I recently came across this paper that in a way they sneakily use value aggregation. And that is one of these benchmarks. So they propose basically what is it called? An ethical score that evaluates the options in a morally sensitive situation. So basically they just kind of do a bunch of stuff and end up with this number here. And that number here is basically product of an aggregation function, right? So sneaky thing, but the hard thing is to justify why their ethical scoring function actually is meaningful in a way. So I'm almost done. So social aggregation only looks simple because you don't have to do any of that complex justification of why this number is what the privacy of this option is or what the beneficence of this option is. But it is tricky because social aggregation absolves you from that, but then you need to find a way to figure out what is representative moral choice when it comes to, this kind of situation. So typically in elections, when we normally use social choice, we take majority view, but it doesn't really make sense in ethical decision making because majority view only makes sense if everybody has a chance to be part of a majority, whereas here we are making one decision for all times. Some moral choices personal should remain to be personal, so nobody should have the right to, even collective society should have the right to override this. How much do we impact when we make a personal choice into a collective one? This is a question that we don't have an answer to. We just kind of say, well, it's going to just be whatever the society decided, and it takes away from you what you could have chosen for yourself. And then there are all the other issues: who has the standing, what information is elicited, and how. So in summary, aggregation is not a silver bullet. It's a viable choice, but one has to be aware of advantages and shortcomings. So human oversight is sometimes taken as like instead of all right, so I'm going to skip this because I'm already at the 20th minute. I just will finish the slides by saying that we are organizing a workshop on machine ethics at AAAI. Unfortunately, paper deadline is closed, but if you happen to be at AAAI somehow, then please come and visit us if you're interested in more machine ethics topics. Okay, thank you.
Thanks very much, Maria. So do we have some questions about your talk, specific questions, or do we move directly to the type of discussions that we could have? So if there are some questions.
May I ask something?
Yes.
Nice talk, Marija. Nice to see you. Normally, moral decisions are based on values, right? And values. How do you think that you can aggregate values?
Okay, so first of all, no, moral decisions are not normally based on values. So that is just one way to do that. And there is no such thing as a value. I mean, this is a little bit contextual. Everybody in AI keeps talking about value alignment, and so on. Value is a specific quantity. What moral decisions are based on is a certain type of evaluation of a deontic status. And the deontic status is basically a concept which they can be different ones. You can have right versus wrong. So you do this because it is right. So what makes it right? You can have reasons for what makes it right. And those reasons
are the values, right?
No.
No?
They are reasons. So I'm just sorry. I'm sorry for being hardline about this, but I have spent way too much time talking to proper moral philosophers that are trying to stop us AI researchers from going off into the wilderness. Reasons can be grounded in other deontic statuses, like this is the right thing to do because I will be respecting my promise, and respecting one's promises is the right thing to do. You see how that goes? So it's like you are grounding everything on reasons. So in reality, values only exist in a specific niche of moral theories, which are these deontic theories in which you have rules for what is the right thing to do, or norms, moral norms that are grounded in some kind of a deontic evaluation of the situation, as it were. So then I would say the right thing to do is the moral thing to do is to shake hands when you meet somebody, because it shows respect, and we want to show respect, right? So there you have a heuristic, shaking hands, that has been built on top of this thing that we want to promote, which is respect, right?
Okay.
I'm not sure how much sense that made. I will refer you to your friendly moral philosopher.
So thanks for the answers. I think that we could discuss a lot about it for a long time. So are there some questions that could address the 4 talks that we have seen? Okay, so I will start the discussion so that you can prepare other questions. So from what we have seen in the beginning when we discussed about multi-agent systems, and from what we have seen in these 4 presentations, I was wondering, so in the first part, in the first session, we saw that we can connect human and users with agents in different ways. We clearly see that we have systems, or type of systems, where we have one human with several agents, one human with one agent. In the last talk that you presented, from what I saw, maybe I'm wrong, but I see several human beings in interaction with one aggregation system, but one single agent in some way. I was wondering, how could we connect several human beings with several agents? We are mainly considering the individual human beings with agents. What about society with a society of agents? I don't know how you see the point, how you could answer to that. Who want to start to discuss about this? Yes, Maria.
So I can start because this is an open problem in machine ethics. Like we can clearly imagine the world in which all of us has a machine proxy, some kind of a helper agent that, you know, makes our schedules or does something. And then the question is, how should these individual agents reason when they talk to each other and try to find something? Like, I want you to evaluate the thesis of my student and I want you to do it during your holiday because it's of interest to me that the student is able to graduate on their thesis. There may or may not be a hypothetical example from today. So then my agent is supposed to somehow convince your agent that is supposed to protect your autonomy and right to holiday to do something that is for the better good. So, and also it's a very good point that in machine ethics, we only deal with one artificial agent at the time. We haven't looked at societies of artificial agents or artificial agents and human agents. So it's like, that is a interesting future problem because I can imagine that there are a lot of to which extent, if you are immoral as a human being, should your machine proxy represent you? Like, let's say I stand for some things that not most of the people consider to be moral. I'm the one carnivore in a community of vegans, right? To which extent will my agent be allowed to stand for me? Let's say I'm a murderer and I want my artificial agent to help me kill people. We can very clearly agree, like, it shouldn't help you to kill people, right? But my moral values, right? So let's not take murder. Let's take something like I'm dishonest towards people, which is not actually illegal. I'm not defrauding them, but I'm actually dishonest towards people. Many interesting problems. I think this is a very pertinent question to ask.
Just to bring some meat more in my questions, I was wondering if maybe the approach that Gustavo was proposing in terms of regulation, if providing some ways for human beings to define the regulations could be a good approach for bringing this into a working system. So, but this is so, Catherine, do you have some answer to that, or?
And how to solve, like how to connect many agents to many humans? No,
Yeah.
I think so. It's a very hard problem. Also in more dialogue systems, more HCI approaches, right? Like the multi-party aspect is a difficult one always.
Okay, and Gustavo?
No, I'm actually interested in your question about the approach I presented to try to regulate that the moral values, or trying to.
So it means that this is still an open question, and maybe this is a very important open questions for the future that is currently built with these several agents that are deployed in everywhere and used by many different users, maybe. Are there other questions about what we have seen so that we can discuss about it? Yes, Alessandro? Marija, sorry. But Alessandro.
No, sorry, Alexandra was first.
Yes, well, I wanted to place the question that I also wrote in the chat because so from if I'm not sure I understood everything correctly, so please correct me if my understanding is wrong. But one question would be, to what degree would you consider that an LLM produced moral judgment? Because you say that LLMs produce moral judgments, not the decisions, are a judgment that is obtained computationally.
Right. So I think
the discussion was that let's say how do we let's say imbue decision making through this done performed by agents, so basically machine code, with moral let's say attributes. And then I would ask if you view LLM produced judgments as being an instance of such computation, because the follow-up to the question that I also put in the chat is whether moral judgments can be obtained by any other means other than resorting to some computation of a utility or value, maybe like Jaime was mentioning, or resorting to deontic logic.
Right. So the moral judgments that LLMs produce are basically an aggregate view that is aggregate from the data that they have been trained on. It's an aggregate view. It is a moral judgment. What they are not able to do is basically reason about that moral judgment. They are just basically giving you an aggregate. To certain, you can argue how accurate or is that to the what you have seen in the data set, maybe, but there is no ground truth. So moral philosophy spends the time to build these systems for moral reasoning. So when you make a moral judgment following a particular theory or a system, then there are good reasons as to why that is a moral judgment, whether it is a arguable, acceptable moral judgment, is it a good one, is it a bad one? You can talk about the quality of it and all that stuff. Whereas what you get from LLMs is basically like putting a bunch of stuff in a pot, mixing up a little bit and see what color you get, right? So do I consider an LLM produce moral judgment to be a machine computational output? It is a machine computational output in the same sense that when I sum up a bunch of numbers on my calculator, I get a sum and it is a computational output. I mean, that is what is happening. Now, the people that I'm co-organizing this workshop with in Singapore, they really strongly believe that moral judgments can emerge from LLMs. I think it's fair to say this was a shotgun marriage by the organizers of AAAI, that they made us merge with them. I'm now really looking forward to see where they're coming from with this opinion that, you know, morality will emerge among machine societies. Curious, I don't know. But my position is what you get as a moral judgment is basically an aggregate view that is from whatever data it was scraped. Typically, this is Reddit.
But this is where the question was going to. Do you consider that that is an attribute of something that the machine computed, or that is essentially it's okay, you can say it computed an aggregate of what people believe would be a moral judgment on that issue if you were to somewhat summarize those views?
I mean, you can ex post rationalize them in some way, I think, but there are so many different ways in which the LLMs flip around with this that, for instance, a master student of mine tried to use ChatGPT-4 to translate normative statements. So this would be kind of norms of the type doing this is right, doing this is wrong, into first order Horn. Don't ask me why. There were good reasons for this. But what we were really interested in is what type of mistakes do the ChatGPT-4 makes when they do this. And what was interesting is that they flip the deontic status of the statement when it is not in line with what normally it occurs. So if I have a whole bunch of sentences, it is wrong to be rude to your co-workers, and there is one statement which said it's actually sometimes okay to be rude to your co-workers, that one gets flipped, and it comes out in the logic as it is not okay to be rude to your coworkers. So because of this behavior, the things get kind of flipped because they're kind of pulled through too many opinions that are represented and so on. I think that it is very tricky to say, yeah, okay, but at the same time, what I'm very concerned about is I've heard that in the US, well, amused, I'm not a citizen of the US, so I can be amused, that in the US, certain judges have started to use LLMs to say that, to justify that this particular position is normally held in society. I don't know much about US law, but
Really?
basically the idea is they do use them as the aggregate view of society, because in some decisions they need to know what the normal view of society would be. So they just basically go to an LLM. So LLM said, this is the normal view of society. Therefore we go with.
How do you know whether one judgment is better than the other one? So you said the one which was the outlier, right? So in some cases it's okay to be rude to your coworkers, right? And that's probably context dependent, right? So how do you know, okay, this context makes that correct, or how? Yeah.
Without an underlying moral theory, you can't really. I mean, with an underlying moral theory, you can take consequentialism and you can compare consequences, or you can take utilitarianism more specifically and see which one brings more good about in the world. You can use virtue ethics and say, well, this judgment is made by an agent that is good, and therefore the judgments they make is good. Or, Confucianism, it fits the role of the agent that the role that the agent has assumed, and it kind of is a good judgment for this role. But without there is a whole theory that are more modern, which it has to be on something is good because there are good enough reasons to do it in a way. And so my brain.
How do you then define what is good enough reasons?
Well, you have to define first what is good enough reasons. Okay. So you're building up this entire system, but without the underlying moral theory, you can't do that. Although there is a lot of work in reinforcement learning that is kind of going after, it's human learned. So enough people think it's good, therefore it's good.
Thank you. Are there other questions?
I had a question for these evaluations of research by AI. And it's more of a curiosity. I don't think there is an answer. Is how good AI reviewers would be to spot something that is truly new and valuable. So because if you have a very brilliant idea and you put it to review, a lot of reviewers will reject it because it's just disruptive and new and so on. And then somebody will see the potential of it, and then it will. I mean, Rao and Georgiev papers were never accepted. And there are so many BDI papers now out there in multi-agent systems. One could argue that, okay, your reviewers were right and there shouldn't be BDI papers out there if you really want to. But I'm really curious about that. The possibility of AI evaluation to spot new brilliance.
I don't know if Irina is still connected.
Maybe she's not
here. Yes,
here.
I'm here.
You're here.
Okay.
Got connected again in time for this great question. Thank you. I think this is a really difficult question for me to respond. The thing is that research is a social process. It's not like you read a lot of papers and then you output a novel idea. You also interact with other agents. You go to conferences, you discuss. You also read social media, you read opinions. Okay, so you use a lot of heterogeneous sources of multimodal information to make up your mind. So that's one difficulty. AI is currently limited because it uses only a collection of textual documents and is not having the equal opportunities to human agents. So this can be improved in future, right? So we can have an agentic framework where AI agents can access various sources of information. also debate with other agents and all of this. But then the other question is, what do we optimize for? You know, so what is a brilliant idea? And the thing is, there is no clear definition of this. And because there is no clear definition, it's very hard to formalize. For example, the ideas can be brilliant, but they are not feasible. So I think if we can clearly define and formalize, then we can fine-tune the agents towards this and optimize for this objective. But as long as we humans do not have agreement on this objective, we cannot create AI that is optimized for this objective. Do you understand what I mean?
No, I understand you perfectly. I just think that the challenge is here that, I mean, my fear is that we somehow as people are able to do it. And part of it is because we recognize something brilliant, and some part of it is because we emotionally get attached to a particular idea and bully everybody around us until we exhaust them and they accept it, right? And then trial of time. So there is this thing that is human persistence in a way. But if, let's say, we replace reviewing by machine, and we eliminate this possibility of human irrationality that eventually champions for things, whether we are going to lose something, right? The emergent danger of getting away with human input and human stubbornness and all of the other qualities that sometimes we judge people for.
In my talk, I claimed for complementary skills. And I don't claim we should replace humans with AI, but I think they bring complementary skills. And for example, AI can be used as a tool to make the judgment more kind of objective, in a sense, more consistent, because AI looks at a very large body of literature. However, the knowledge of an average human is very limited to the literature that human has seen, right? So because of this, reviewing is so subjective because people have different background knowledges. And the background knowledge, as we show in our research, is a crucial factor for the judgment if something is novel or not, or brilliant or not, right? So that's why I think human and complementary and AI can be very complementary. However, the technical challenge is how to organize this human AI workflow. So how to make it work. And to this, we currently don't really have a good solution, but we do propose some ideas in our vision paper, how such co-construction could work in an accountable way.
I understand.
So your answer raises the very important questions. It is about the way these models have been built. And so if there are some biases on the data that have been used to train these models. So it is a multi-agent approach maybe a solution for these questions. If we have multiple models that are cooperating with each other, models built in different ways, and trying to cooperate and co-construct all together some kind of judgment. I don't know. This is an open question. So, Jaime, do you have some elements to discuss or questions?
I want just to add something about what Marija and Irina just said. There is also the case that what is potentially a brilliant idea is considered as such because of ignorance. I mean, this is the issue that we have all the time when reviewers, you need to review a paper which is just not in your area of knowledge, and then you think something it's very good, but in fact you didn't know that somebody has tried before and has completely failed. So, and I think that Olivier raises an excellent point, which is if we control, I mean, if we had, let us say, an information repository that is good and fair and controlled, and we have everything that anyone has written about multi-agent systems in archived stuff, then perhaps we could change. Another problem is the one of the reviewer who is not acquainted with the domain, since this is exponential and we are not dealing with this in a good way. So I agree with Irina that could be complementary in this stuff. And it's multi-agent because you put everybody, and the multi-agent stuff that you said, Olivier, how it's solved today by negotiation. I mean, you have the PC chairs, the SPC chairs. I'm talking about reviewing, right? Then you have people said, "Oh, I didn't know that," and I don't know. So I think that doing this in multi approach, it involves several actors. Definitely, it's the way we know how to do it. We don't know how to do it in another way. I'm not claiming that it's perfect, but it's better than the one that relies on one opinion.
Yes, it's solved by negotiation, but it also solved by regulation. In some way, you could ask and you could oblige the agents and to provide some proof, so to be accountable for what they are proposing. So I think that multi-agent approach is maybe a good way to ensure all of this, and taking into account also the environmental impact of all these computations that we are creating. Okay, so if there are some questions, no, maybe no more. So I would like to thank all the speakers for these very exciting talks, amazing talks. Thanks for all these discussions that we had, and all the participants that stayed for most 4 hours in front of their screen. So this is a very big, challenging issue. So the webinar was recorded, so we will put this on the ENFIELD website. The speakers will send us also the slides so that you can also have access to them. And for all information about ENFIELD, I saw that in the chat there are some questions about when the calls are open on this. So you can find all this information on the ENFIELD website. And so I hope that you will participate to the next webinars. We have one that is open that will take place in 4 days about green AI, which is quite an important topic also. How can we diminish the impact of AI? So thanks to all of you, and hope to see you soon in other discussions. Have a good day. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Thank
Nice
you.
meeting you.
Bye-bye.
Bye.